Buongiorno a tutti. Vi chiedo di cominciare a prendere posto che tra qualche minuto iniziamo.
Quando
Sì.
fai? Va puntato verso
Sì, lo so.
la regina, forse sei tutto perfetto.
Grazie. Poi diciamo che la primissima parte sarà in italiano e poi il resto sarà in inglese. Sì, 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 sì. Sì. Tu vuoi, magari potrebbero loro puntare il nome di questo. Però secondo me la chiavetta, ma sì, non è bene. Direttore. Quasi pronti, abbiate solo un attimo di pazienza. For those of you not speaking Italian, the very first part will be in Italian, and then we will switch to English for the technical program. Esatto, questo è il messaggio. Sì, Nicola, siamo pronti.
Buongiorno a tutti, benvenuti. Siamo molto felici di ospitare questo meeting qui a Palermo. Grazie anche perché so che da un punto di vista logistico è stato un impegno per tutti, ma noi siamo ancora più felici, diciamo, di sentirci un po' più al centro. Quindi è un segno molto importante per noi aver organizzato questo meeting qui, e di questo ringrazio Nicola e Antonio, perché voi sapete, noi come Palermo in realtà siamo entrati nel programma attraverso le Cascade Call, ma in realtà ci siamo sempre sentiti parte di questo progetto sin da quando abbiamo iniziato insieme a concepirlo. Quindi questo è stato proprio un progetto in cui tutta la nostra comunità scientifica è stata coinvolta in maniera veramente inclusiva, e l'organizzazione di questo meeting a Palermo penso che sia una dimostrazione anche di questa attenzione a tutta la nostra comunità. Volevo dire proprio 2 parole sul nostro programma, ma prima volevo ringraziare il nostro direttore, il professor Ivan Fratini, per l'ospitalità, e il nostro prorettore alla ricerca, il professor Andrea Pace, perché questa è un'aula del Dipartimento di Ingegneria dell'Università di Palermo, e devo dire che entrambi ci hanno anche supportato tantissimo nel portare avanti questo programma, cercando sempre di trovare delle soluzioni efficaci a tutta questa macchina complicata che abbiamo messo in piedi per rispondere a questa sfida del PNRR. Ci avviamo al 3° anno del programma, quindi ci avviamo un po' a una conclusione, stiamo finalmente vedendo un po' dei nostri risultati, ma soprattutto stiamo cominciando a pensare a come valorizzare questi risultati in un'ottica anche un po' più di lungo respiro per il post PNRR. E questo è anche il motivo per cui questo workshop è focalizzato sull'innovazione, l'innovazione per guidare il nostro futuro, quali sono i bisogni di innovazione delle aziende, dell'ecosistema delle telecomunicazioni e quali dei risultati dei nostri progetti, quali delle nostre attività possono rispondere a questo bisogno. Quindi il programma è stato proprio organizzato con un focus sull'innovazione, e ringrazio tutti quelli che hanno contribuito a vario modo. Abbiamo 27 presentazioni tecniche, vado un po' a memoria, parleremo delle grand challenge trasversali dove sono coinvolti molti dei colleghi di vari progetti del programma. Abbiamo 3 panel industriali dove appunto discuteremo i bisogni di innovazione delle aziende dell'ecosistema, dai provider di infrastrutture, gli operatori ai verticali, e soprattutto coinvolgeremo tutta la nostra comunità di giovani. C'è anche una sessione di 60 poster, molto partecipata, e abbiamo qui proprio davanti alla nostra aula la sessione dei dimostratori. Io per il momento avevo piacere di dare la parola al direttore e al prorettore. Facciamo parlare prima il nostro prorettore. Grazie di essere qui.
Grazie Ilenia, grazie a tutti e benvenuti a Palermo. Per chi viene da fuori ancora arriverà. Ti ringrazio per l'invito e lei è abbastanza preoccupata di quello che avrei detto oggi. L'ho tranquillizzata che avrei utilizzato 3 semplici parole chiave, perché questo è un progetto non da poco, qualche centinaio di migliaia di euro, giusto? Più o meno 3.000 euro più, 3.000 euro meno, e quindi quando si parla di budget spesso si pensa a cosa progettare, cosa comprare, però ci sono 3 cose insieme a tante altre che difficilmente si possono comprare o hanno un valore economico, e sono la ragionevolezza, la fiducia e la collaborazione. La ragionevolezza perché nella fase progettuale, quando si esplorano tante possibili iniziative, tanti possibili partner, ognuno ovviamente, come si suol dire, tira la giacchetta a chi ha la possibilità di progettare, e la ragionevolezza è l'elemento chiave per mantenere gli equilibri e portare a casa un risultato che è un successo nei fatti piuttosto che sulla carta in fase progettuale. La fiducia ha a che fare anche con l'affidarsi a qualcuno nel momento di maggiore incertezza, e credetemi, nell'ambito del PNRR incertezza ce n'è stata sempre abbondante in tutte le fasi, nelle fasi di valutazione, nelle fasi di implementazione, come sicuramente vedrete anche dopo, anche per il futuro. Quindi è importante avere fiducia, e così come quando si è su un mezzo di trasporto pubblico cercare di non distrarre, non disturbare, ma non distrarre il conducente, e questa è una cosa altrettanto importante. Collaborazione, che non significa fare qualcosa in cambio di qualcos'altro, ma mettersi a servizio di un qualche cosa di più grande. Perché questa sfida che è stata colta a livello di PNRR è una sfida in cui è stata tolta principalmente alle università e al settore della ricerca pubblica la scusa numero 1, la mancanza di fondi. E quindi abbiamo una sfida innanzitutto di dimostrare come sistema della ricerca di sapere utilizzare questi fondi per il meglio e che per il totale del risultato non sia la somma di tanti progettini, perché altrimenti sarebbe stato inutile organizzare tutto questo bailamme. Lo so che siamo alla facoltà di ingegneria, ma qua dobbiamo dimostrare che 2 più 2 fa 5. Mi dispiace, professore Fratini, ma 2 più 2 dovrà fare 5, 6, no 4,1. Ok? E quindi questa è una sfida veramente, veramente importante. E questi 3 concetti posso testimoniare indipendentemente dai ruoli che ha l'Università di Palermo. Il progetto Restart li tiene insieme sin dall'inizio e spero che continuerà a tenerli fino alla fine e oltre. E quindi ringrazio soprattutto tutti gli attori di questa avventura con cui, diciamo, mi sono interfacciato, sicuramente la professoressa Tinirello all'interno dell'Università di Palermo, ma il professore Blefari, coordinatore del progetto, e anche i 2 colleghi prorettori che si sono avvicendati in questa avventura presso l'Università di Tor Vergata, la professoressa Daniela Vuri e adesso Massimo Federici, che sicuramente in qualche maniera, diciamo, stanno vivendo e stanno diciamo, partecipando a questa avventura cercando di risolvere gli stessi problemi. Un particolare ringraziamento anche alla collega Adele Del Bello, che sicuramente, diciamo, fa parte di questo motore, di questi ingranaggi, e se si fermano gli ingranaggi poi si ferma tutta la macchina. Quindi buon lavoro a tutti, sperando di rivedervi nelle prossime puntate di questa meravigliosa avventura, e do la parola al direttore del Dipartimento di Ingegneria, professore Livan Fratini.
Grazie prorettore, grazie intanto alla professoressa Tinirello per il gentile invito. Devo dirvi che non è la prima volta che il Dipartimento di Ingegneria ospita riunioni per progetti, per misure del PNRR a cui partecipa l'Università di Palermo. Il Dipartimento di Ingegneria è ben lieto di avere la possibilità di ricevere così tanti colleghi ed è ben lieto di partecipare a consessi di questo livello, a livello nazionale, per lo sviluppo di questo tipo di progettualità. È chiaro che siamo nel pieno del frullatore, sta iniziando il 3° anno, siamo nel rush finale. Noi siamo contenti, noi finalmente abbiamo le risorse, noi docenti, noi siamo stati messi nelle condizioni di collaborare con network che si sono costituiti a livello nazionale, sicuramente di pregio e sicuramente ad alto livello. Le nostre amministrazioni sono un po' meno contente e soddisfatte, anche a causa degli aggiornamenti ministeriali sugli aspetti burocratici, però abbiamo avuto la bicicletta e stiamo pedalando. Siamo molto contenti di avervi qua oggi e mi fa piacere porgervi il mio personale benvenuto. Mi fa anche piacere ringraziare la professoressa Tinirello che si è mossa con questo progetto con attività puntuali, con attività di pregio, valorizzando il gruppo di Palermo che in qualche modo coordina, e quindi noi siamo ben lieti oggi di averla qui, di essere con voi, di ospitarvi per questi 2 giorni. Del futuro, richiamando quello che diceva il professore Pace, il prorettore, del futuro, diciamo, ce lo giocheremo via via. In questo momento dobbiamo cercare di consolidare per quanto possibile i risultati attesi e i deliverable dei progetti a cui partecipiamo. Io lavoro su un altro partenariato esteso e quindi conosco le specifiche regole del gioco di questo tipo di attività. Finora il gioco è stato condotto con energia, con determinazione, adesso c'è da chiudere la partita nell'ultimo anno e quindi evidentemente lo sforzo finale è particolarmente rilevante. Anch'io vi auguro buon lavoro, ci vedremo in questi 2 giorni e ringrazio ancora la professoressa Tinirello.
Prima di dare la parola ad Antonio e Nicola, Volevo ringraziare ancora il direttore e il prorettore per il loro saluto e dare qualche piccola informazione tecnica. Grazie ancora e buona giornata. Per le presentazioni dovreste raggiungere la regia in fondo, chiedere di caricare le presentazioni direttamente da chiavetta USB, oppure potete mandarle per posta all'indirizzo micheleCardella.events@gmail.com, però suggerisco di andare direttamente in fondo alla sala per il caricamento delle presentazioni, per poterle trasmettere in streaming. Volevo dire un'ultimissima cosa: tra le varie iniziative del programma, sapete che abbiamo tante iniziative anche multidisciplinari. Oggi abbiamo una collega di Tor Vergata, Antonella Poce, che nel pomeriggio parteciperà ad una visita, ad una mostra che ha contribuito ad allestire presso Palazzo Bonocore. Si intitola La mostra Palermo Felicissima. In questa mostra saranno valorizzate anche alcune delle tecnologie del nostro progetto per nuove modalità di fruizione dei musei attraverso realtà aumentata e realtà mista. Se avete degli accompagnatori che sono con voi e che sono interessati a partecipare, segnalatelo al nostro desk, perché la collega avrebbe piacere di portare con lei eventuali accompagnatori. Altre informazioni logistiche le discutiamo via via, non vi rubo altro tempo e diamo la parola a Nicola.
Grazie. Grazie Elenia, grazie a tutti i palermitani organizzatori, grazie a voi tutti di essere venuti. Per mettere sulle slide come faccio? Sì, ma devono prima mettere... Grazie Antonio. Meno male che c'è Antonio.
Io lo faccio.
Allora, buongiorno, sarò breve. Sono cose che conoscete quasi tutti, ma ci sono parecchi colleghi nuovi e quindi a loro beneficio ripeterò alcune delle caratteristiche principali del programma, oltre a dirvi qual è lo stato dello stesso, riportando anche i numeri che abbiamo mandato ai revisori recentemente, e concludo con qualche riflessione. Allora, questi sono i partners originari, erano 25, sono diventati 27 perché ci sono state delle gemmazioni, tra cui Tim e Leonardo, quindi sono 27 i programmi, i partner diciamo così, del fondatori. Sapete che abbiamo avuto 2 cascade calls, la prima più rilevante è ormai conclusa e quindi qui ci sono diversi colleghi che sono entrati con questa prima call, ed è in corso la seconda cascade call con un budget più limitato e con obiettivi un po' diversi. I loghi non li abbiamo tutti perché non ce li avete ancora mandati tutti, ma qui ci sono quelli che ci sono arrivati. Quindi per il momento noi abbiamo ben 116 partner, gli originali 27 più 89, di cui 44 università, 3 centri di ricerca e il resto sono partner privati che includono, come avete visto, come sapete, operatori, vendor, fornitori di tecnologia e piccole e medie aziende. E quindi riuniamo una parte significativa dell'ecosistema nazionale delle telecomunicazioni e quindi abbiamo una grande opportunità. Questa è una slide chiave che presentiamo sempre, a cui teniamo molto e che fa vedere che il programma è diviso in 7 missioni, di cui la prima e la più importante è la ricerca, la quale è costituita da 32 progetti nei quali sono inseriti anche i nuovi colleghi entrati tramite bandi a cascata. Ma ci sono, lo ripeto sempre, queste altre 6 missioni a cui io tengo in modo particolare, e mentre la ricerca va bene, devo dire siamo soddisfatti, anche gli audit che abbiamo visto, i revisori sono soddisfatti della parte di ricerca, Questo tutto sommato l'abbiamo sempre detto, no? Conoscendo la qualità della nostra ricerca non avevamo dubbi che la parte di ricerca andasse bene e sta andando molto bene. Siamo molto soddisfatti anche in termini di indicatori, Antonio ve ne parlerà, ma tutto molto bene. Però la vera occasione di questo programma sono le altre 6 missioni. Io capisco che il nostro mestiere è diverso, ma se non investiamo una parte piccola del nostro tempo, un 10% in queste altre cose, questo investimento non avrà i risultati sperati. Sarà una fase di aumento della produttività e poi torniamo dove eravamo prima. Invece usare questo significa aumentare la base su cui lavoriamo. E quindi, non so se sono tutti qui, in primis i responsabili di missione hanno una responsabilità grande, possono ancora in questo anno fare molto. Il budget c'è, io lo ripeto da anni, i soldi ci stanno, se vogliono fare qualcosa, i soldi ci stanno, li possiamo trasferire, basta avere idee e soprattutto realizzarle. Quindi in termini di laboratori, in termini di trasferimento tecnologico, di supporto alle start-up, attività di education and training. Oggi Antonio lancerà una lodevole iniziativa di tutorial che va in questa direzione e che complementa un po' questa missione. Le attività di dottorato e l'attività di comunicazione. Ecco, la comunicazione, devo dire, mi complimento con Agnieszka, non so se c'è qualcun altro, sta andando molto bene. È una delle missioni, forse se posso esprimere un giudizio, che sta facendo molto bene il suo lavoro. Sulle altre, direi, ho mixed feelings, per così dire, come si dice in diplomazia. C'è sicuramente spazio di miglioramento e, vista la base che abbiamo, questo anno deve essere teso soprattutto a migliorare questa parte qui. Sulle Grand Challenge non dico molto, ne parlerà Antonio. Questa è un'altra cosa importante per mostrare i risultati, quindi per far vedere in modo tangibile che c'è qualcosa dietro la ricerca e a cosa ha portato tutto lo sforzo di ricerca che è stato fatto in questi 2 anni. Non vi annoio con i numeri, queste sono tabelle che faremo circolare. C'è questa forte pressione a spendere i soldi, perché, lo sapete, adesso ci saranno revisioni, a parte ci sono degli obiettivi contrattuali, noi ci siamo impegnati a spendere questi soldi entro il 31 dicembre, non ci siamo, secondo me rimarranno soldi, perciò dico, e lo dico da anni, il problema non sono i soldi. Se volete soldi e avete idee e li volete spendere, ci stanno. Poi in futuro non so, adesso ancora sì, perché se guardate le percentuali, noi oggi abbiamo speso il 48%. E siamo a 2 anni e 2 mesi, quindi è evidente che non ci siamo. Questa è l'ultima volta che abbiamo rimodulato, diciamo così, in modo trasparente. Ve lo dico, cosa voglio dire? Che c'era un budget iniziale che non rispettavamo, dopodiché vi dicevamo volete rimodularlo perché non avete speso per questi X mesi, quindi siete sotto. Tutti quanti avete detto sì, è vero, quindi spostiamo in avanti le nostre previsioni di spesa. Così, se confrontiamo il modello e le simulazioni, fino al giorno attuale va tutto bene, perché abbiamo rimesso a posto i conti prima. Ma la divergenza dopo aumenta sempre. E non potete adesso dirmi che spenderete tutto il 31 dicembre 25, perché adesso avremo una sessione col Ministero e rimoduleremo dall'alto, perché ci sono cifre obiettivamente imbarazzanti. Il CNR sta al 15% se contiamo anche le cascade call. Quindi non possiamo lasciare queste cifre, quindi su queste interverremo e quindi i soldi ne usciranno fuori a milioni. Peraltro ieri sera, tornato dalla cena, ho visto per la prima volta queste cifre che mi ha mandato Adele, che ringrazio sempre insieme ad Anastasia che non so se sta qui, e ho notato che Tor Vergata è la prima dell'università. Lo dico perché siccome non è merito mio, allora sono sorpreso di vedere questo grande risultato, dovuto secondo me in gran parte a Luca Chiaraviglio e a Francesca De Angelis, che non vedo qui ma ringrazio molto, perché Tor Vergata non è che avesse questa amministrazione brillante, se posso lavare un po' di pane, siamo sempre tra amici, però sta al 70%, quindi vuol dire che si può fare. quindi con un po' di impegno si può fare. Evidentemente in verde sono quelli che stanno sopra il 60% e gli altri sono messi male. Sul fronte reclutamento siamo messi abbastanza bene, ormai siamo a regime, la fondazione funziona, devo dire, abbastanza bene, un po' in affanno per cose che ci arrivano tutti i giorni in termini di incombenze, ma abbiamo un team che vedete qui elencato che funziona a mio parere molto bene e che ringrazio. Ne dico i nomi perché lo meritano, quindi c'è Adele Del Bello, Giuseppe Caserta, Roberta Cristofori, Anastasia Di Lorenzo, Agnieszka Furman, Vittoria Kerstic, Federica Loffredo, Ilaria Mancini, Fabrizio Mariani, Gianluca Massei, Alessandro Melino e Angela Soldà e altre persone che assumeremo in questi giorni. Vedete, assumere queste persone ci costa parecchio sforzo perché bisogna fare un concorso pubblico, abbiamo 18 quanti candidati, 30 candidati, bisogna fare tutti quanti i colloqui, è pesante, no? Però poi avremo queste 5 persone e vale la pena poi avere questo aiuto. Invece diversi partner ancora non hanno assunto queste persone che possono assumere sull'overhead il 3%, che è una cosa assolutamente tranquilla, perché non bisogna rendicontarla. Quindi qui ci sono dei soldi che partner non stanno usando da ormai 2 anni e con questo recruitment ancora in progress. Poi ve le mando queste, non per esporvi al pubblico ludibrio, ma veramente, insomma, cerchiate di velocizzare questa parte. No, assumete questo personale di supporto a fine programma, non si sa che ci si fa. Sul recruitment invece scientifico siamo messi bene, dovevamo assumere 103 RTDA e siamo ufficialmente a 96, in realtà un po' di più, e quindi al 93%. Sui dottorati siamo al 97%, sui dottorandi, e sugli altri ricercatori siamo al 106%. E nelle more delle comunicazioni ad Arthur diciamo che abbiamo raggiunto il 100% dei nostri obiettivi, il che mi toglie uno dei pesi che avevo nel soddisfare i requisiti del programma. Quindi su questo fronte siamo messi bene. Le cascade call, il primo round si è concluso, quindi tutto a posto, dovresti essere qui presenti, presentanti. Il secondo è in corso e spero che si velocizzi questa parte e quindi tutto sommato possiamo essere soddisfatti fin qui. Guardando un po' a quest'anno che ci resta, intanto vi faccio tanti auguri perché ieri adesso Giuseppe poi comincia a farlo è il Capodanno e oggi è il primo giorno del nuovo anno del Serpente. L'ho messo perché se uno va a vedere l'oroscopo dell'anno del Serpente, l'anno del Serpente simboleggia saggezza, intuizione, cosa che voi tutti avete, e trasformazione, che io interpreto in modo digitale, quindi trasformazione digitale. Noi dobbiamo quindi avere questo 25 che deve essere l'anno dei risultati. Dobbiamo produrre risultati. A me non piace molto la parola impatto, no? C'è questa pressione dell'impatto. Dobbiamo produrre risultati, che sono anche algoritmi, sono anche procedure, però dobbiamo avere risultati da poter mostrare. Ci sono anche delle prospettive di carriera, secondo l'oroscopo cinese nel 25, quindi per i giovani sono dei breakthrough di carriera. Vi esorto a esercitare pressione sulle vostre amministrazioni, sia per spendere, perché dedichino risorse, perché una responsabilità di tutto questo sta anche nelle amministrazioni evidentemente, perché potevano prepararsi un po' meglio sapendo che arrivavano questi soldi, o comunque dopo che sono arrivati. Ma c'è un altro punto che richiamo la vostra attenzione e che forse sarebbe degno di uno sforzo coordinato. C'è la cosiddetta massa critica, che sono le vostre ore rendicontate, e l'overhead, che è la percentuale del vostro lavoro rendicontato, che sono rispettivamente 28 milioni e 4 milioni. Questo dobbiamo ottenere che le università, anche nelle aziende private adesso è un pochino più complesso, mettano a disposizione questi fondi dei ricercatori che li hanno prodotti. E siccome c'è un po' un effetto trascinamento in cui le università dicono siccome lì fanno così, facciamo anche noi così, eccetera, cerchiamo di fare un fronte comune. Perché questi sono parecchi soldi, sono soldi che rimarranno, che possono essere usati come volete, perché non sono da rendicontare, su cui ci si possono fare investimenti ulteriori, uno ci può arrivare alla pensione con un tesoretto lasciato lì, o ci può fare degli investimenti. Quindi potremmo, Adele, cercare di fare un po' una ricognizione dello stato di questi fondi nei diversi partner, cercando poi, tramite rappresentanti legali, di spingere per chiarire da subito qual è la situazione e di ottenere il meglio possibile, in modo concertato, così siamo più forti rispetto alla trattativa singola, insomma, no? Perché da quello che so, diversi atenei, invece di trattenere, che so, 10-15% che normalmente si fa, cercano di prendere di più. Cercare, lo ripeto, di sfruttare tutti gli strumenti e le opportunità di restart in termini di personale di supporto anche da assumere, per alleviarvi dal compito di amministrazione. E infine, e chiudo, l'ho detto per mail ma ve lo ripeto, con CNIT e Francesco De Natale stiamo organizzando questo evento che si chiama Telecommunication of the Future, che è il vecchio 5G Italy rinominato per ampliarne il campo di applicazione, 8 e 9 aprile. Ci piacerebbe che partecipassero tutti i nuovi. Io lo ritengo davvero importante. Noi abbiamo assunto 100 RTDA, 100 dottorandi e altre tipologie di ricercatori, CNR, assegnisti, eccetera. Sono 250 persone. È una cosa veramente importante. Allora, dovrebbero venire tutti, a mio parere, anche perché dovremmo parlare delle loro prospettive, perché stiamo cercando di organizzare una sessione facendo vedere quali sono le possibili prospettive e cosa possiamo fare noi per aiutarli in queste prospettive, nell'università, nel CNIT, in Restart, presso le aziende partner. Quindi è veramente importante che vengano tutti. E siccome il CNIT deve prendere una sala, e la sala che prendevamo fino agli altri anni teneva 250 persone, noi abbiamo un'opzione che scade per la solita sala, ma se poi vengono questi 250 più gli altri 250 non c'entrano. Allora noi abbiamo chiesto di iscriversi entro il 31 gennaio. Cercate di farlo, quindi di sollecitare intanto i presenti tutti, ma anche i vostri dottorandi, i vostri ricercatori, dite a tutti per favore di iscriversi, così lo sappiamo. Grazie. E grazie. Anastasia mi criticherà per la grafica del grazie, sicuro. Il colore della e non si vedeva. Poi ieri era dopo cena, insomma. Grazie ad Adele, Anastasia, Antonio, sempre. Grazie.
So let me now continue in English for the rest of the program, and we now start for the part which is more dedicated to the technical content of our research program. Can I have my slides on, please? Capone. Dite sempre il cognome ad alta voce quando arrivate qui, così mettono le slide. Let's wait a second. Great. So, as usual, I will give you some very high-level the progress of the technical part and the research part in particular of our program. Comment on how we are going and what we can do in the last year. Let's see. L'antenna. As Nicola was saying, we have a number of key performance indicators that are used by the communication mission for monitoring how we are going in terms of the results that we produce. And of course, there are a number of scientific KPIs that are related to the number of scientific papers. We are almost at 900 scientific papers that have been produced by Restart, with also a very high number of joint publications. So we set at the beginning a very challenging target of 30% of publication joint between different research groups and research institutions. And this is interesting because, again, this was one of the targets that we had at the beginning, trying to increase the collaboration among different institutions, universities, research centers, and companies in our community. But not only, we are also trying to increase the outreach activities in terms of seminars, dissemination workshop, and keynote speeches in different conferences. Overall, we are, for most of these indicators, we are above the target that we set at the beginning of the project when we submitted the proposal. We are also going pretty well in terms of communication. Again, this was another important goal that we set in the proposal, trying to make our work visible to the outside community, trying to, again, bring back telecommunications at the center of the attention of the general public. We have been helped, of course, also by the news in the media in these days, somehow, right? Bad and good news. And this is somehow changing the situation with respect to the beginning when we started 2 years ago. For a number of reasons, people are understanding that the telecommunications infrastructure is fundamental for the development of the economy. This was clear during the pandemic, but considering the last news, this is continuing, and people are more and more aware of the importance of investing in these technologies. And the initial idea of restarting the attention in telecommunication somehow is now witnesses in a number of results that we are obtaining, and in general that we can see in the attention that has been dedicated to telecommunications. And if you think, for example, that the recent Draghi report had telecommunication as one of the pillars for the proposal for relaunching the European economy, you can understand that somehow we had a good idea in trying to invest in this direction, and our community showed that we were ready to at least take this challenge and bring this challenge for trying to create something new and generate an impact in our sector. For trying to really summarize the results of a big program like this is very complicated. One of the ideas that we had, also stimulated by the international reviewers, was that of creating some meta indicators, meta milestones that are based on how we are going with respect to the work plan that we have and in terms of the results that we are achieving during the program. As you can see, we have been, in the last report that we submitted to the ministry, we are now almost at 100% of the results achieved in all the indicators and for all the eight spokes that we have. So all projects are well on track. We had a complete set of internal audits for all the projects, and also for the grand challenges. I will mention the grand challenges in a second, during November and December. And as we were expecting, all the people involved, all the researchers and colleagues involved, they are doing a very good job in the projects that they are working on. As Nicola mentioned, in the last period, the most important novelty that we have is that we had a cascade call completed in all the spokes, and now we have enlarged very, very much the community from 27 partners to 116. One important characteristic of the way we shaped the cascade call is that those cascade calls have been designed trying to fill the gaps in the projects that were already ongoing in the program. So we enlarge the community, which is not easy, in particular in the middle of a complicated program like this one, but this has been done incorporating the tasks covered by the new colleagues and partners that join the program directly into the work plan of all the 32 projects that we have. So basically, once the administrative procedure had been completed, they were already up and running, able to integrate their work in the projects. And it's happy to see that the reports that the projects are producing are already incorporating this work, and that, in particular, the last part of the program that they have set is based on the contribution of these colleagues that have joined the Restart program. In particular, in the last year and in the last part of the program, what we expect and what we also will have the pleasure to have the contribution from the partners that have joined with the Cascade Call is an effort in the direction of creating and demonstrating the results of our work into demos and experimental platforms. So this part is fundamental because, of course, we produce a number of papers that have important scientific results, but showing the results into demos is fundamental for having the results appreciated by a larger audience. All the events that we will organize during the last year of the program will be focused on trying to give visibility on the many demos that all the projects are preparing in this last part of the work. And this is fundamental because, again, showing these results can help in increasing the impact of the work, having companies interested in the results, and generating interesting collaborations for the period after the end of the program. This will require an additional effort from our side, because, of course, organizing a plenary of 2 days like this one with speeches is not easy, but compared to what we need to do in the last year, in which we need to create the condition for showing demos, for bringing demos into the events that we organize, will be more complicated. So for sure, we need your help. I already stimulated all the principal investigators of the projects to work in the direction not only of completing the work and having the demos ready and working, but also to figuring out what is the best way of showing these demos and having people appreciate the work done. As you know, in addition to the project, we started these grand challenges. This is the name that we gave to these initiatives, that are cross-project initiatives dedicated to create impact, in particular on those areas that are more promising, that can have an impact in terms of results that can be generated. Of course, this has required an additional effort for coordinating activities in different projects, and in some cases also adding new activities involving some of the new researchers that have been recruited during the Restart program. One of the important goals that we have is that all the grand challenges, 19 grand challenges that we have, will generate at the end a white paper. So we will have somehow something that will show this effort of working cross projects for finding a way for creating a connection between activities of different projects in different domains with different expertises, and trying to show what are the potential applications of the results that have been generated. This is not the only goal of most of the challenges. The first part of this morning will be dedicated to some short presentations of the coordinators of the grand challenges. We have divided the grand challenges, there are too many, in clusters, and we have appointed a coordinator for each of the clusters in order to also coordinate activities among different challenges. So we will have a brief overview of what they are doing, and I hope that for you will be also interesting understanding the work that is being done, and in case you want to collaborate, you have the opportunity, of course, to contact the coordinator and try to see if you can give your contribution to these activities. Another new initiative that we launched a couple of days ago is that of trying to also disseminate the experience and knowledge that we are generating in Restart also to a larger public, creating a series of tutorials on telecommunications. Again, these tutorials, as usual in scientific conferences, can help in particular young researchers to know what is being done in a specific research domain. I can come up, yes. But we are targeting different type of audiences, not only the research community, but also the general public or people with general knowledge, technical knowledge in telecommunications. And the idea is that these tutorials can be done online so that the participation is very easy, quick, 1 hour and a half in the evening. So we will, I'm sure we will have a rich set of proposals that will generate an interesting program. This is another opportunity, again, not only a waste of time for you for preparing the slides and giving the tutorial. Again, it's another opportunity to have people know your work and understand the potential impact of the main activities that in Restart we are doing. Finally, the program. Elena already mentioned how we are organized. Let me just mention that all the talks and the industrial panel that we organized have been focused on innovation. We asked to the companies that will participate to the industrial panels to try to explain during the panel what is their point of view in the needs of innovation perceived by the industry in our sector. We do good research, of course, but we know well that sometimes the research directions that we take are not completely in line to the expectation of the industry. Trying to focus on innovation means basically trying to see the opportunities of the exploitation of the results of the research, but also listening to the needs of the telecommunication sector that not always are aligned to the research that we do. So we will try with the panels to hear the voice of the companies, and in the talks, the researchers that have proposed their talk, they've been asked to try to focus again, not only on the scientific results that have been generated, but also on what they see as innovation that can be used in their work. So this is how the program has been shaped. We'll take, of course, the 2 days of the program. I will not give you the details that you can read in the program, and you can download with the QR code that is presented in the first slide. I'm stopping here, and I thank you for your attention. Almost perfectly in time. So the first speaker of the first session, which is dedicated to the grand challenges, is Michele Zorzi, University of Padova.
Thank you, Antonio. Good morning, everyone. Zorzi. PowerPoint, non PDF. Okay, so the grand challenge that I'm going to present is number 1, networks hard to die, which is designed to address disaster type of scenarios and situations where the communication infrastructure is either compromised or absent, and we try to put together something that enables communication in different situations here. So I'm Michele Zorzi. I lead this initiative, which relies or connects to 3 projects within Restart. 2 of them, I'm actually the PI, Sextet on extreme environments, Aquasmart on coastal monitoring, and then there is ITA NTN on non-terrestrial networks. So this initiative involves many partners of Restart, including academics, companies. Also, we reached out to government entities, so we are in touch with the Protezione Civile of the Veneto region to act as an end user and to help us define KPIs and requirements, and so this is very useful. So the scenario, as I mentioned earlier, is one where something happened, either natural or human-made, which leads the pre-existing communication infrastructure to be compromised and not work. And clearly, in the situation where we need to provide relief to the population hit by the disaster, communication is critical, both for responders to communicate among themselves and with their command and control center somewhere, and also to try to reach and to find survivors in the scenario. And so there is both a communication infrastructure need, but also there is a sensing aspect in a broad sense, where user devices, so the smartphones or people who are under a collapsed building, can act as sensors, send signals, receive signals, and notify responders of the presence of people in some areas. And so this sensing angle gives this flavor of the communication / sensing type of infrastructure. And so what we would like to do is to see how we can help these first responders to do their job effectively and to provide them with all the communication needs they may have. Now, since the communication infrastructure is not there, then we need to provide a temporary replacement for that. And so non-terrestrial networks seem like a natural choice. And so the satellite network, which is generating so much discussion these days, clearly is a facility which will serve this need, but then it's not obvious that we can communicate directly to satellites. And so one idea is to use flying objects or as temporary base stations. These flying objects will be connected to the satellite network for internet access, and they will act as temporary base stations or access points to provide communication infrastructure locally with the nodes that are in the area. Now, there are many design tasks in this scenario. There is an issue about controlling these flying nodes, how many, where they should be put, how they communicate with themselves. There is an architectural issue, which, again, how do we serve the traffic needs of this scenario with a certain numbers of these nodes and how they communicate with themselves, all the protocol stacks and everything. Then the system, the sensing system design, which I mentioned earlier. So all of this should be integrated and work effectively. Clearly, a central role is played by the UAV, the drone, which is both a base station and a sensing hub. And so this exceeds what typically we can have in commercial products. So we need to think about an UAV which is more capable than we can find today. And there are issues, for example, a satellite antenna mounted on a flying object is quite a challenge because of pointing and stability. And so that's one thing. Then computational capabilities related to the sensing task. So there are many issues that call for going beyond what is available today on the market or even in research products. So the local area network is also a bit of a challenge. We can rely on the drone to act as a base station, but then we can leverage on device-to-device communications, for example, using nodes there. And so there are different architectural choices we can make and different protocol optimization that can be made. The sensing system I mentioned, so the phones of users is one element. The hub in the drone is the other element. We can have also additional sensing devices like LiDARs that responders can bring with them, and so all needs to be integrated. So we identified three different possible architectures here. So the satellite is always a key component to provide internet access. So one possibility is we just bring some vehicle, a van, which becomes a base station. This is typically done today. So this is connected to the internet via the satellite, and then the van connects with the nodes. So the advantage of this is that the van is a stable object, so you can drive there, stop, do all the calibration of the antenna connection to the satellite and everything, and then it's done. You have your network up, not very flexible, not very flexible, but effective. Now, one step forward could be, well, let's have a moving base station, so a flying object. So to solve the problem with stability of the antenna and satellite connectivity, we have a van which connects to the satellite, and then there is a wireless link between the van and the drone is the base station. Okay, so it's a kind of multi-hop type of scenario, which makes it more flexible because the drone can be then driven where we want it to be, and so it can at different times cover different areas and so on. You can optimize dynamically. And then, of course, the ultimate architecture, which is the most difficult, would be the one where there is no van in between, so the drone connects to the satellite and provides connectivity to the users. And so we want to address these three architectures and to understand pros and cons, costs, benefits, and technical challenges, how we can address those architectural protocol issues, plus a number of other issues, because we have many aspects that need to be taken into account. And as I mentioned, we are in touch with the Department of the Protezione Civile in the Veneto region to help us define the KPIs, understand the requirements, understand also the operational conditions of these kind of scenarios, where it's not just about communication performance, but there's a lot other technical issues as well as non-technical issues related to the population and the emotional burden and other things here. So one important requirement is that all nodes that belong to users, like phones essentially, so these should not be required to have anything beyond a commercial device. So you cannot expect a survivor to have on their phone either hardware or software which goes beyond what is typically available, right? Because these people have a regular phone, and so we have to build anything in addition outside those nodes, so in the architecture or in the other nodes. So this is an important requirement. So as I said, besides the communication performance, energy consumption is clearly an issue here, but also if you have flying nodes, then the aerodynamics of the antenna, for example, because think of a drone and then just think of sticking on the drone a dish antenna that doesn't fly very well, right? So we need to address these kind of issues as well, plus all the back end and the tracking and the sensing. And so it's a complex problem here. So there are challenges, in many areas. I don't think I'm going to go through all of them. You can kind of figure, what many of them are. In terms of facilities, we in Padova we have this what we call Extreme Lab, where we bought a number of pieces of equipment related to wireless communications, plus in collaboration with the spoke of Catania, we are buying also 2 drones to experiment with these things, and so we are well equipped to try to demonstrate some of these functionalities and to evaluate, at least preliminarily, some performance of this kind of system. So what we want to do is to, of course, study all these scenarios and produce scientific results about design, optimization, and ultimately implementation of these kind of solutions. But also we would like to demonstrate some part of this. And so we are creating a task force of researchers from the different partners participating in this initiative. And the idea is that the task force should meet in person a few times from now to the end of the year and come up with some implementation of an experimental facility with which we can then demonstrate some of the functionalities that are being studied in this environment. And so if you are part of this initiative, you will probably know already that we are looking for people interested in joining this team and to devote some time towards this final demonstration. If you have not been involved in this initiative and you would like to, of course, we welcome anyone who wants to join and wants to help us doing some work. Companies and operators are especially welcome because, clearly, besides the research that needs to be done on the optimization, then we need to also look at the implementation and also take care of some issues that clearly, fall in the areas where industrial partners, vendors, and operators are competent there. So we hope that within a few months we have designed the demo, and by the end of the year we can actually show something and show that these ideas work. So with that I will stop, but let me mention that, of course, a lot of what Restart is pushing for relates to demos, impact, implementation, but we all know that behind that there's a lot of good theoretical research that we all do. And so if you don't know about this, I'm actually the general chair of the IEEE Communication Theory Workshop, which will be held in Venice in the month of May. So the deadline to book the hotel at the special rate is actually tomorrow, same as the event in Rome. And if you like to join this event, there's a website and everything, so please consider that. And with that, I think my time is up. Thank you.
We don't have time, unfortunately, for questions in this first part, but quick comment for you. So then, not everything is solved just using Starlink, right?
Right. I mean, we may use Starlink, but yeah.
Thank you, thank you, thank you again. So the next speaker is Sergio Barbarossa from University of Rome, La Sapienza. C'è il Barbarossa.
Barbarossa.
Tieni qua.
Mi fai segno? 2 minuti.
Sì, sì, sì. Questo PDF è giusto? Sì. Può mettere in full screen? No, c'è uno.
Com'è possibile? Ok. Ok.
Ci dovrebbe essere un pulsante per fare full screen, non so che software sta usando.
But can I move the pages? Oh, yes. Oops.
Okay, so let's try this way. Sergio,
Okay.
go ahead.
Sorry for the inconvenience. Thank you, Antonio. Good morning to everyone. So, as the title says, I will concentrate on this aspect which is very relevant today, how artificial intelligence can be made more pervasive through the use of networks. Please keep in mind that there are two major ways in which AI and networking can work together. One way is using networks to make AI truly pervasive, which is what I'm going to focus today. And also there is the other way around, where we are going to use AI to improve the efficiency of networks, which is a different aspect that actually involves most of the partners here. So, well, okay, here is just a list of the other Restart projects that are contributing to this grand challenge. And I take this opportunity just to mention that, of course, this is free. So if you are interested in contributing, please feel free to contact me. Can you adjust the slides, please? Because you see, we see two, vediamo due slide insieme. Com'è il problema? Okay, looks good, thank you. So we have a short-term plan. Essentially, we want to complete a white paper within the project, and also we want to push for collaborations, because as I said before, this is truly an activity that pervades, that is present in many projects. And then we also have in mind the proof of concepts, which are, as the other speakers mentioned before me, and 3 of them are included in the project Netwin that I have the pleasure to coordinate, and they are about a mobile intelligent robot. I will say a few words later on, and then on-demand AI using UAV, which is related to what Michele Zorzi presented before, and then to artificial intelligence aided extended reality. But we also have a long-term vision. Let me say we have the ambition to have an impact to the evolution from 5G to 6G. As many people say, 6G is going to be AI native. There is not a single definition of what this means, but in our mind, AI native networks means a network that since the beginning includes AI blocks within the network itself, so that the design is made taking into account this availability. And so we want to have an impact on this evolution. Okay, if I have to mention some of the key points where Restart is contributing into this roadmap, the first one that I want to mention is developing distributed knowledge representation systems that can be fundamental for semantic communication and coding for machines. And the second point that I want to highlight is how to make intelligence move across the network, essentially moving across the edge cloud, to enable AI services which are delay critical, because only moving the application together with the mobile user, we can be able to ensure strict delay constraints and possibly minimize energy consumption. The third one is bringing intelligence on demand using UAV, an activity which is related to the previous talk, but here we will focus on AI services. The fourth one is AI-aided extended reality, how we can improve this quality of experience using artificial intelligence. The last one is very broad in principle because it's distributed machine learning and learning and inference across the network. So let me go quickly. Well, still have the same problem. Anyways, I hope you can follow me. So the first topic I want to mention is semantic communication, an idea that started when we were proposing the proposal for Restart. At that time, could look like a weird idea, but if you look at the number of publications today, there is an exponential increase, thousands of publications in the subject. So very briefly, what's the point here? The point is that in many applications, if you take the real goal of the application in mind, you can design a source coding methodology that can be more efficient than conventional methodology. Why? Because you focus on the real application that is demanding the exchange of information between transmitters and receivers. This is just an example, for example, for autonomous driving, what really matters is the capability to identify pedestrians, traffic signs, etc. So while coding the images that are produced by a web camera inside the car, it's useful to take into account this semantic representation, which can be given in this case by a semantic map. Now, if we go to the performance, just to mention what we can get, in information theory, one of the fundamental concepts established by Shannon is how to achieve the optimal rate distortion trade-off. Okay? So here what we do is we try to extend this concept. So we want to define a rate distortion, but for distortion we have a sort of semantic distortion. What is a semantic distortion? Is a distortion as perceived by someone like a human, for example. In the case that I mentioned before, the distortion could be defined like the probability of identifying the pedestrians correctly, to be able to estimate, for example, the 3D, the depth, distance from the camera, and so on. So we defined a set of KPIs, semantic KPIs in this sense, and here we have the rate distortion trade-off. So we have in the x-axis we have bit per pixels as before, because essentially we are transmitting bits as in every communication, of course, but then the KPIs are different, and we compare here what we achieved with state-of-the-art image coding, and as you can see, we can have a very significant increase in this rate distortion trade-off. Of course, there's no magic. There's nothing wrong in Shannon. We cannot say we are doing something better than Shannon. Why? Why do we gain with respect to Shannon? It's because Shannon coding is universal. Universal meaning that you can encode and decode, and this is irrespective of what you want to do with those data. You can do whatever you want. Here we are restricting the application. For example, in this case, we're saying, if I'm transmitting images, I want to make sure that all the pedestrians are correctly identified and positioned in the image. This restricts the number of applications, but this is what gives the big advantage in terms of rate distortion trade-off. Now, moving on this aspect, in all this area, what it's becoming a new paradigm is to really think of communication as a big deep neural network Part of it is on the transmitter side, part of it is on the receiver side. Then, of course, a major issue is to make these things as simple as possible, because, of course, there is an increase of complexity. And then one of the activity carried out by the FAM Media project, coordinated by Enrico Magli, is to make these deep neural networks as small as possible in terms of bits, in terms of coefficients, etc. So what they did, they used a strong quantization. They just used -1, 0, 1 levels for each neuron in this DNN, and then they pruned the network, so they cancelled, removed a lot of nodes, up to 90% of the nodes, and still they were able to achieve performance very close to the state of the art. And I think this is another big step towards the vision of a network like a lot of distributed deep neural networks. Then the next talk, maybe I should be very brief here because Michele said many things here. It's about bringing intelligent services on demand using, for example, drones. And what I want to highlight, especially in what has been done in the project that I'm directing, is the fact that even though we are all aware of the significant, problem in having these drones with a Wi-Fi platform, so the capability to act as a radio access point, and possibly the need of performing some processing on board. Nevertheless, my colleagues in Trento and Siena, essentially, they were able to now have drones. I can show some of them here. And they were able also to bring a GPU inside the drone. So the drone has a significant processing capability, which adds much more. So the drone is not only just a radio access point that you bring to where is necessary, when and where is necessary, but it also has a significant processing capability. Then the other point that I want to mention, this is essentially an activity performed at Logogramma together with Fastweb, and now there is a collaboration with University of Naples, Federico II, and Tor Vergata. So what has been produced until now is that there is this system, essentially is a virtual assistant. You go to a museum, you look at the painting, and then a hologram appears and starts communicating with you using a large language model. But then the people working on this field addressed some of the major problems related to LLM today. This is a very hot topic these days, DeepSeek, ChatGPT, and etc. Some of the major problems with LLM is that they may have hallucinations, so they may say something totally wrong, and there is lack of explainability. And then a lot of research has been done in this context to try to limit, possibly eliminate hallucinations, and to give more explainability. This is essentially performed using these techniques called RAG, which stands for Retrieve Augmented Generation, where you want to use generative AI, but you want to condition the generative mechanism according to what you know for your specific applications. And this, I think, it's a fundamental step. Then we have this activity in FAM Media about a human cyber twin. So essentially, the cyber twin, as the name says, is a copy of the human. And then if you really want to have a very good quality of experience here, you want to use also AI to predict behaviors of the user in order to optimize the communication between the human and in its twin, if you want. This is another important activity. It's a proof of concept present in NetTwin. So here the idea is that you have a robot. This robot looks around. He has a specific task. In this case, the example was recognizing a specific person. And then the robot moves. What is the technological challenge here? The fact that, as I mentioned at the beginning, you want the AI move with the user. So while the user is moving, the radio access point is going to change, but also the computation is moving. Okay, and this has been made possible implementing this recognition system using microservices, stateless microservices, and exploiting Kubernetes, so that you have very light virtual machines, and they can be migrated across the edge network. And if you look now, this is really present, is an activity carried out by Perugia and University of Rome Tor Vergata. You look, you see this, you will see this robot moving, and it gives the impression of being intelligent. Of course, there's no intelligence here, but he's exchanging data with the server, and the server is moving through the migration of these light virtual machines. And then there is a big field. Here I had to compress in just one slide for economy of time. But the point here is distributed in many projects. And here I just made a list. Essentially, the major contributors here are PESCO, in terms of projects, PESCO, FAMedia, Netwin, etc. The topics are distributed learning and inference, and they have to do with the impact of the network topology with the distributed learning, the robustness to network failures, federated learning and unlearning. What if you take something out of the network? A resource-efficient pervasive intelligence, asynchronous federated continual learning. Continual learning means that you don't learn something and then you do inference, but you keep doing this through time. And also federated learning with heterogeneous clients. I'm going quickly to the end. So in conclusion, I think that networks are expected to play a key role in deploying these pervasive AI services, essentially because they can control the delay, especially for delay critical services. And the other major point is the development of distributed knowledge representation, where generative AI plays a key role. As I mentioned here, in this grand challenge, I only mentioned one way of the interaction between AI and networks, how networks can help AI to be closer to the end user. But there is the other way around that I mentioned at the beginning, and I'm sure that many projects are involved with AI to make the network design more efficient. And as I said, the ambition is that Restart can play a role to provide the vision of how next generation AI native communication networks can be. Thank you for your attention.
Thank you, Sergio. Maybe just a quick comment also from your side. I mean, as you know, AI is one of the hot topic of the moment, and everybody's now is also looking at the recent news on some interesting novelties in the field. But apparently, the attention is only on models, computational power, and that's it. And to be honest, very limited on impact of the network. What do you think can be the key aspect that will make everyone aware that the network component can be crucial in the future development of AI?
Well, if you look if we have let's say a long-term vision, so we look ahead where the amount of data that can be communicated can be huge. Have in mind holographic communications and so on. These things are accelerating at a step that we have never seen before. So at some point, there will be the need of managing this information with some more knowledge, let me say. Okay? And the second point is that to to make these networks more efficient, of course we need some intelligent mechanism inside, which I didn't mention here, but it's going to be present in any case to improve efficiency. And the third aspect is that we are now immersed in this, AI everywhere. Even in the smartphone now we have AI services, etc. So this is something that should be taken into account, and in my view, since the beginning of the design of the communication network. It has to be part of it. As thinking also deep neural networks as part of the blocks of the tools to be used, it's going to change. Of course, you mentioned something that is crucial, because up to now, especially the learning part is a very costly one, okay? So what they are doing is that they do it once, a while, because they use a lot of energy. But this is one of the crucial steps that we researchers have to address.
Thank you. Thanks again, Sergio. So the next speaker is Davide Dardari, and we are now moving on a completely different topic, more based on technology with Davide. So Davide Dardari presentation. Dardari, please, can you put on the slides?
Okay, good morning to everybody. Yeah, this is a completely different topic. So it's the band propagation to the needs of the network. So what is the meaning of this? So for the time being, we all design wireless networks. So I'm focusing mainly on the physical layer, on the wireless networks, taking the environment as an input to be estimated, and then trying to optimize the network, so the transmitter receiver, in such a way we, let's say, improve some key performance indicator. So thanks to new electromagnetic, let's say, structures, as well as new signal processing schemes, methods that take into account these new technologies, it is possible now to, let's say, put the environment in the optimization loop, what is called the smart radio environments. In such a way, we can optimize the environments, also, not only the transmitter, the receiver, in order to further improve the performance of the network. So this is one side. So basically include the environment in the optimization process by deploying, let's say, innovative electromagnetic devices. And, but there is also the possibility to reduce the digital bottleneck, that is trying to move part of the processing that today is made in the digital domain with all the consequences we have in terms of energy consumption, delays, and so on, and scalability, directly into the electromagnetic side, so that perform some signal processing task at the electromagnetic side, so that we can save energy, we can reduce the latency, and so on and so forth. So this is the more or less what this kind of grand challenges considers, so that in order to overcome some of the limitations of the 5G technologies, especially for what regard the energy consumption, the scalability, and at the end of the story, to make future wireless network more sustainable. Well, this is the approach we are following. So this is the list of some of the projects and labs that are involved in this grand challenge. Obviously, this is an open list, so that everybody who is interested in joining this grand challenge is welcome, especially, let's say, companies. And so we have some structural projects. So the project SRE, which is actually on smart radio environments, the focus projects MOS, CGYNet, IN, and also the Spoke 7 lab of Naples. But we have also the interest of an external entity, which is the European Research Infrastructure, so big data, so which is a federated pan-European structure that, let's say, is interested in joining this grand challenge. So the approach follow is the following. So we start from what is going on, what is currently studied within each, let's say, project, trying to identify the key innovations of these projects. At the same time, let's say, identifying the labs demos that are currently under investigation in the project and create synergies, identify synergies with the purpose to, for instance, integrate components that have been developed in different projects, or let's say create common testbed platform. In other words, to create the conditions in order to validate the technology developed in a broader sense. For instance, in testing them in more realistic scenarios, so that in order to have a better idea about what could be the impact of these technologies. Just some examples of the innovations that are currently under investigations in the project. So the first category is related to the new electromagnetic metamaterials and technologies. Here you can see a list of, for instance, metaprisms that are frequency selective passive metasurfaces, conformal smart skins that are a sort of, say, electromagnetic sheets you can bend around objects such as poles in the street, so that to facilitate the coverage without actual additional cost. Outdoor and indoor surfaces, so surfaces that can be put close to the windows or the external walls of the building in order to facilitate the penetration of the electromagnetic signal from base stations that are outside. Another example is given by high-frequency devices, for instance, liquid crystal-based terahertz reconfigurable intelligent surfaces. So these are some examples of innovation that we identified within the projects I listed before. In terms of new electromagnetic materials and metamaterials technology, but there is also the part related to signal processing and information theory, so that methods that can take advantage of these, let's say, building blocks of these new electromagnetic structures in order to improve the performance of wireless communications in a wide sense, but also enabling new applications. Provide new functionalities. For instance, ray tracing risk modeling, some models developed in particular the project MOS have been embedded in commercial ray tracing tools, machine learning for link blockage prediction, signal processing algorithms for communication localization that exploit these new metamaterials, backscatter communication, so communication with a sensor, for instance, that are deployed in the environment, that basically are able to transmit information without generating new radio frequency signals. So just recycling what is already on the air. Okay? So this basically allows very low energy consumption. And finally, wave-based computing. As I mentioned before, the possibility to perform computing directly at electromagnetic level. Last but not least, it is also important to investigate fundamental limits. So here we have new technologies, we have new scenarios, so the question is, what are the theoretical limits? So what is the best we can imagine, we can do with this technology? So that in some projects we develop we investigated such limits, in particular for scenario in which we have risks. We are working in the near field propagation regime, which is quite an unexplored way to communicate when working at high frequencies with very large antenna arrays. Okay, so in addition to the innovations, let me just show very briefly some of the labs demos that are under development. This is the millimeter wave risk-aided communication lab at the Politecnico di Milano in collaboration with our partners. So the main goal of this is to create a sort of realistic environment in which all the technologies mentioned before, for instance, metaprisms, smart skins, and so on and so forth, can be tested so that we can assess the performance. We can compare different solutions, so we can compare the advantages and disadvantages of smart skins with respect to risk, with respect to smart repeaters, so that to understand whether one technology is better suited for one particular application, etc. So that, in a few words, to assess the potential impact of this technology. Similarly, another, let's say, demos in this case is outdoor-indoor smart electromagnetic surfaces. This actually is an initiative that was not present initially in the original project. So this is a new initiative that started thanks to the Grand Challenging, let's say, initiative. And here the idea, as I already mentioned before, is to design and test outdoor-indoor smart electromagnetic surfaces. For instance, in order to reduce the transmitted power of the base station or reduce the number of the base station. Another example is that of the Uniroma 2 proof of concepts, which is a proof of concept with the purpose to test RIS prototypes in FR1, FR2 bands, again to test the coverage and the capability of these structures. And another purpose of this lab is to support the Meta-Celestini demo, which is a demo foreseen in the MOS focus project. Was purpose to, let's say, replicate the Guglielmo Marconi experiment in Bologna using new technologies to celebrate the 150th anniversary of Guglielmo Marconi. So this is the picture of Villa Grifone. And finally, this is the Big Data European Research Infrastructure. And here is an open lab, it's a federated lab that can, let's say, provide facilities to test high-frequency solutions. In particular, one idea is to test the liquid crystal RIS working at terahertz in a, let's say, wider context in order to validate such new technology, sub-terahertz actually. Well, so to conclude, these grand challenges is a great opportunity to put together different fields, metamaterials, electromagnetic theory, information theory, signal processing, in order to improve some fundamental KPIs, such as lower the energy consumption, improve the coverage, low latency, provide less electromagnetic pollution, and also enable new applications in order to make future wireless network more sustainable. So this is the great challenge to reduce the energy consumption and also improve the scalability of the wireless networks. Okay, thank you very much.
A quick question also for you. I mean, one of the challenges inside the challenge is that of understanding how these kind of solutions can be really deployed in a network, right? Of course, you know, there are different type of networks, the mobile networks with macro coverage, indoor coverages, specific technologies, industrial areas, and so on, right? And of course, the cost part is one of the, fundamental, limit that can prevent the use of this technology. Where do you think are the most suitable scenarios where these kind of solutions can make a difference? And what do you think on the combination of the sensing part and the use of metamaterials for trying to improve, the efficiency also of what is expected to be one of the fundamental components of 6G, which is sensing in addition to communication?
Thank you for the question. Yes, I think that perhaps one of the most appealing scenario for these kind of technologies, particularly for regard the, say, risk, smart skin, and so on, is the industrial scenario. In any case, control scenario, because in this case it is clear who is going to pay. Whereas in outdoor scenario, that is not still very clear, and then that's why one of the challenges is, within the challenge, is to compare different solutions in not only in terms of performance, but also in terms of cost and energy consumption, and so on. Obviously, the sensing is an important aspect which is under consideration. For instance, thanks to these technologies, you can see around the corner, for instance, without adding new devices. So this is an option. We should not forget that we should not think about smart radio environments as only risks. Okay, because as I mentioned before, there is also another aspect related to the electromagnetic computation that can be applied to the base stations. So now we are moving towards extremely large array, extremely large everything. So what about the scalability? So that is it possible to have a sort of hybrid scenario in which hybrid, let's say, base station, in which we have some part perform in the digital domain, some part in the analog domain, some part in the electromagnetic domain. So what is the best combination in order to make the system scalable and to reduce the latency, the energy consumption? So this is another challenge inside the challenge that we are taking into consideration.
Thank you. Great. So the next talk of this session will be by Giulia Fasoli from Scopia. Scopia is one of the industrial partners that joined up with a cascade call. Okay, and Giovanni Corazza from University of Bologna. And the topic is, let's say, as Nicola said last time, this is the mother of all the challenges, understanding the future of telecommunications. So please.
So I will introduce Giulia, because this is the time of the meeting in which we go beyond telecommunications. As Antonio was saying, we have a problem, Houston, we have a problem. What is the future for the telecommunication industry? What is the role of Europe? What is the role of Italy? What is the risk of being irrelevant on the geopolitical scene? Nobody knows the future, of course, but there are methodologies. It's a discipline in itself. The way we look into futures, always using the plural. This discipline is called future studies, and the methodologies are strategic foresight methodologies. All large corporations in the world have a department of strategic foresight. Most governments do, Italy does not. And the European Commission, since the last mandate of von der Leyen, has one of the vice presidents of the Commission, which has the mandate for strategic foresight. So we're bringing these methodologies to you, and Giulia will talk about an exercise that has been done in the last months on strategic foresight, opening up different scenarios in order to be ready. Nobody knows what the single future will be, but in order to be ready, you have to expand the possibilities. And of course, this involves both quantitative and qualitative methods. Now, the Osservatorio of the Politecnico of Milan has been doing, and you've seen the position paper, excellent work at the quantitative level of expanding possible features in the short term. What Giulia will talk about is the medium-long term. We know less, but we need, in order to make strategic decisions today, to have a vision of possibilities around the future. Giulia is working for Scopia. It's one of the new partners that has come in through the Cascade call. Scopia was founded by Professor Roberto Poli. He's not here today, but he is the UNESCO chair for anticipatory systems. And UNESCO and the United Nations have futures literacy as one of their priorities around the world. So what you're hearing now, it's a little different. It's not technology, but remember, it's something that around the world is being talked a lot, and it's felt as a priority. Giulia has a degree in sociology, so she's not an engineer, so she will have a different vocabulary, different communication style. So let's welcome Giulia to our community, and thank you very much for being here.
Thank you, and good morning, everyone. Thank you, Professor Corazza, for introducing me. And as he mentioned, I'm here on behalf of Scopia Anticipation Services, which is a consultancy firm specialized in future studies, futures literacy, and foresight methodologies. Foresight is, in fact, one of the innovations of the Net for Future project, and we talk about the future, we work with the future, but today specifically we will see how future methodologies can help the telecommunication sector and digital ecosystem to face the uncertainties we have and we will see in the next years. So, what? Okay, I'm sorry. I'm going to tell you about a workshop that was organized in collaboration with the University of Bologna during last November, and it involved, in fact, foresight methodology and particularly scenario building. That is one of the core methods of strategic foresight. We invited experts from the telecommunication sector, from both the academy and the private sector. Today I'm going to share the process, the scenario we developed, and what I would like to transmit is that they can be used as decision-making tools to take decisions in the present and shape the future we desire. So, first of all, I'm going to provide a definition of strategic foresight. And we chose the definition from the European Commission that defines foresight as the discipline of exploring and anticipating future possible developments to shape the preferable future. So it's not about forecasting or prediction, but it's about imaging alternatives and act today to shape tomorrow. Strategic scenario is the method we used and we proposed during the workshop. We chose the Shell method, which is named after the Shell oil company, because it's the most used in company and telecommunication. Because it helped Shell company to prepare for the oil crisis of the last century. So it proved to be really impactful. It works. Okay. What you can see in the slide, it's the matrix of the strategic scenario. The axes represent the most impactful and uncertain forces that were identified by the participants to the workshop. So looking at the matrix, we could reflect on two questions. What we will see in the future, and we choose 2050 as a time horizon, will be hyper-connected smart cities or more localized networks? And will Europe unify under a single digital system, or will fragmentation dominate? So as you can see, if the axes stretched have the urbanization force, urbanization and deurbanization, and a strong European Union and the European Union breakup. So let's dive into the scenario. 4 alternative visions have resulted from the workshop. The first one has been titled United States of Europe. The second one, City States 2.0. The third one, Distributed States of Europe. And the last one, Digital Feudalism. Let's briefly dive into each scenario and see the characterization. So in the United States of Europe, obviously European Union becomes a unified and cohesive entity, fostering robust technological regulation and large-scale urban development. So here keywords are the European power, centralization, smart cities, and each scenario has opportunities and risks. So opportunities in this case are the consolidation of the European operators into a strong, globally competitive network, the expansion of fiber networks and digital infrastructure, and the development of smart cities with seamless digital services. On the other hand,
We wish this was true, of course.
we wish, of course. On the other hand, risks are an over-centralization that could lead to vulnerabilities, especially if populist movement gain momentum, but also we talked about cybersecurity in a over-centralized scenario. And the other risk is the dependence on large-scale systems that could reduce local flexibility. The second scenario is city-state 2.0. So we have a high level of urbanization, but we are in a situation where the European Union breaks up. In this scenario, Europe fragments and city-states and metropolitan regions dominate, but we saw a growth of economic inequalities, and also technological development becomes uneven. So the opportunities are municipal and metropolitan operators that led to localized innovation, AI that drives new digital products, but also, on the other hand, risks are a market fragmentation that limits interoperability and efficiency, and a growing digital divide. The third scenario is the distributed states of Europe. And this vision focuses on a decentralized Europe with strong local developments and economies, and localized production and sustainability that are prioritized. In this case, keywords are the European power, as we have a strong European Union, local decentralization, space economy, local sustainability, local technological production, smart territories, and an European army. So as you can see, in the development of each scenario, participants focused also on geopolitical tensions or societal shifts. It's really a rich vision from a variety of points of view. The first scenario is digital feudalism, where a hyper-localized world emerges and where communities rely on cooperatives and local institutions. So keywords are community cooperation, localized economies, and limited technological progress. And the risk is to lose competitiveness and innovation in the face of great geopolitical powers such as the United States or China. So what can we learn from this scenario? We choose three important lessons: flexibility and resilience. Each scenario, in fact, highlights the importance of adapted strategies that account for uncertainties. As I said before, the axes chosen were the forces that were considered most impactful and uncertain by the participants in the workshop. Then the second point is strategic testing. Organizations can use and should use this scenario to test their current strategies against diverse future. Let's think about how your business can perform in a scenario or in another scenario. The same business can perform in very different ways. And then the third lesson is the collaborative planning, because by involving different stakeholders and also different point of view across sectors, foresight fosters shared visions and collaborative innovation and networking. So in conclusion, this scenario represents a tool for stakeholders. They can be used to create future-proof strategies, as scenarios themselves are not strategies. They can be used to build strategies. And by providing this scenario, the project offers, and that's the innovating point, offers a flexible framework for organizations, institutions, and enterprises to challenge their current approaches and ensure resilience and flexibility to possible futures.
Thank you.
Thank you.
Thank you. Let me just comment on this a little bit, because this is one of the important activity that we are conducting in Restart, and as Giovanni said before, there is another part of the work that is being done in Milano with the team of the Department of Management Engineering, and we presented in a workshop dedicated the white paper that we prepared, and in the event in Rome in April that Nicola mentioned, that we will present the second version of this white paper, which will be more focused on, again, the scenarios which are a little bit different from this one, because again, for the first time, we have been setting a collaboration for trying to create a bridge between short, medium-term scenarios and medium-long-term scenarios. So during this last year, we will ask for your collaboration in trying to put the technical activities that we are doing, imaging a technological evolution as an input in this work, and also this work can help you also in understanding a little bit more how the type of innovation that you are generating in the project can be somehow placed into an evolution scenario, which of course has a number of variables in a larger ecosystem, which of course also involve the economy, the players in the economic players and the geopolitical situation. It's interesting because again, this was also a goal that we set at the beginning of Restart, trying to force a little bit the technical community, the research community, in having also a vision of the context in which we are working, and also understanding the economy and the geopolitics that is behind the changes that we see is fundamental, right? In particular, in a topic, in an area like telecommunications that we are very well understanding in these days, it is crucial in all the balance, the geopolitical balance around the world. So my suggestion, my invitation is to try to participate more in these activities. Ask us. There is Mattia Magnaghi there, sitting there, who is one of the team members working in Polytechnic on the other part. Scopia and Giovanni are here, and try to get in contact if you want to contribute. Of course, you can download the first version of the white paper from the webpage of Restart, and also the work that with Scopia will be done will be then published and placed on the webpage. So this is really an invitation to all the community to participate to this activity. I don't know if you want to add anything.
The only thing that is constant is change, so we have to be ready.
Yes, definitely we need, and in particular in a sector like this one, we really need to be ready for changes that will come in the near future. Thanks again. So this concludes the session. Now we have a break, so we will resume at 11:45. But from now on, there will be the posters in the ground floor available. Sorry? 30, okay, so we will resume at 11:40. Okay, great. 11:40, so we can resume earlier in the session. Take the opportunity. The posters will be available from now on until the end of the day. There is one important announcement that we started already in the plenary sessions of Restart. You will be able to vote for your preferred poster. There are some rules, the same rules that we applied also last time. So we will have an award for the best posters, and you will have a QR code next to the posters for voting for your preferred poster. You cannot vote for the posters of your institution, right? If there are authors of your institutions in the poster, you cannot. We will check, right? We will check. So there is a form. So you, with the QR code, you will be forwarded to a form, and you can vote for your preferred posters. Again, it's a game, nothing more than a game. But for the young researchers working hard in Restart, is a little, recognition of their work. So please take this seriously. Okay. Thanks again, and let's have our back. Siamo pronti a riprendere? Se la mia voce si sente anche fuori dall'aula, spero. Intanto chiamo Giacomo Bernini, dove sei? Ok, ciao. Chiedo gentilmente alla regia se può cominciare a mettere le slide di Giacomo. Perfetto, così la gente capisce che stiamo per cominciare. Il problema è che il coffee break era troppo buono. Se uno mette dei biscotti brutti, automaticamente la gente torna prima, invece con quella roba lì. Ciao. Poi è andata anche Anastasia, se riesci. La minaccia è una roba difficilissima, però.
Staccare la gente dal buffet
non è facile. Sai cosa bisogna? Bisognerebbe fare il gruppo WhatsApp appena ho un braccialetto deve avere scorso prima. Presidente, almeno di compagnia il capo perché devo cominciare. Una minaccia un po' mi togli. Okay, very well. We are ready to resume our session. So this is the part 2 of the session dedicated to the grand challenges. The next speaker is Giacomo Bernini, Nextworks. Nextworks is another company that joined through the Cascade calls, so in the large group of Restart. He's been actively participating and coordinating the grand challenge associated to the orchestration, network orchestration, again, which is probably one of the most important because, of course, as implications and application scenarios in different domains. So Giacomo, please.
Yes, thanks for the introduction. Yeah, and thanks at least those that are in the room for coming back from the very nice buffet that is outside. So the Grand Challenge 10 is about trying to make the network a platform for running, let's say, applications and services. And it's related to, let's say, the big scope of management and orchestration of future networks and services. And so we are pretty much involved in this activity as Nextworks. The actual coordinator is Carla Fabiana Chiasserini from Polytechnic of Torino, but so we are working with them in the super project from which this work has been originated, together with other projects that I will mentioning at the end of my presentation. Just a quick outline of the presentation. So we'll go through some kind of key concept and challenges that at least so far drove the activity of the Grand Challenge. An overview of the architecture of the, let's say, orchestration solution that the Grand Challenge is defining. And then a brief insight on a few of the design principles that rely, let's say, on alignment with standards, in 3GPP mostly, but also others, we believe it's key in this type of activities to foster adoption and also interoperability. And also some insights on some of the technological enablers that are part of the architecture, just to give a brief introduction on this as well. So in terms of, yes, main concepts, so as I was saying at the beginning, the goal is to, let's say, make the network a platform for programming and running applications. And this lays its foundations basically on the softwareization of networks and infrastructures and services, combined also with the emerging extreme programmability and disaggregation of network technologies and solutions that first with 5G and later, as it will be with 6G, this is emerging more and more. And this requires indeed a kind of management and orchestration platform and architecture that allow to, on the one hand, benefit from these, let's say, evolutionary concepts, but also cope with the complexity that this brings. So the idea is indeed to derive this conceptual architecture that is based on few concepts that you see listed in the slide. First, talking about management and orchestration, we believe that aligning with the 3GPP concept for the service-based management architecture is key to adopt, let's say, a solution where we have cooperative management domains and management services that are loosely coupled and allow to manage with different mechanisms, different network technologies and different abstractions of the networks. Of course, as it was also mentioned in some of the previous presentations, there is a need of, let's say, allowing distributed and pervasive network intelligence inside of the network, but also to manage this and consider the fact that there are many technologies deployed in the network infrastructure and also different domains. Network programmability, as I was already anticipating, and disaggregation brings a lot of flexibility in how to configure, operate the network and the services, but also brings some complexity for operating it. That's why, for example, automation is one of the key aspects to introduce, to reduce the operational costs and also to benefit from this extreme programmability to provide tailored services to the verticals and to the end users. Of course, as I was also anticipating, the adoption of open standard interfaces is mandatory. There is a lot of effort in the standards to define architectures and let's say APIs and interfaces at different levels from different standard bodies in 3GPP, in ETSI, GSMA as Industry Forum, also TM Forum. So for interoperability, not only at the network, let's say, and the hardware level, but also on how to manage and operate the end-to-end infrastructures. Of course, this was also mentioned in one of the presentations from other Grand Challenges. we need to cope with the fact that this telco cloud concept, let's say, introduce this cloud continuum that allow to deploy applications, AI functions, up to the extreme edge, which means up to the device, so beyond the RAN network. And so we need to address the challenge of orchestrating services and applications that can run also on the device, that could be drones or even personal devices. Of course, automation means introducing what we call a closed loop approach, where indeed the optimization goals for network and services can be diverse and tailored to specific services, and can be, of course, also somehow conflicting each other. That's why coordinating these automation principles is fundamental. And it's where, for example, in this Grand Challenge activity, network digital twins, we believe, allow also to facilitate and to enable to test also closed loop automation and coordination. Of course, the introduction of AI, integration of AI as a pervasive functionality is a must as well, as it was also mentioned by Professor Barbarossa. In the Grand Challenge, we try to address also this aspect of both directions of AI for the network and network for AI, and that's why those MLOps capabilities to facilitate trustworthy, explainable, and native AI is considered with an AI as a service approach that I will introduce later in the slides. And then, of course, intent-based approach, transversal to the architecture, to allow, let's say, simplified interactions with the consumers, for going beyond the, interface based on very complicated attributes and schemas to request for a service or a capability. This is what for now has been the result of the Grand Challenge in terms of architecture for this management and orchestration solution for future smart networks and services. It is a multi-layer architecture that basically lays on top of this compute continuum that spans from the extreme edge up to the cloud and allows to deploy multi-tenant virtual environments that allow to deploy network functions across different domains, from access to core, also to the transport network. On top, there is the proposed architecture that at the lower level includes domain-specific, let's say, orchestrators that focus on, let's say, controlling and orchestrating specific domains, from the radio network to the core network to the transport, with different SDN solutions, for example, that cope with different type of technologies, and resource orchestration more for the cloud continuum. You see multiple boxes in all of the domains, because this type of architecture that is service-based allows for different implementation of the same functionality, allowing and improving the multi-vendor interoperability also at the management side. On top, there are a set of so-called end-to-end management and orchestration services that indeed rely on the services exposed by the lower ones to, let's say, enable end-to-end slicing, also inventorying of the computing resources, monitoring and data analytics for specific domains, and even more on top, end-to-end services that can span across different domains and possibly also across different vendors, and have also capabilities for end-to-end service and network analytics. All of these gray boxes introduce also and have the scope to introduce automation. Automation is also one of the key goals for future networks, especially with 5G advanced and 6G. So automation will be also facilitated by these pervasive and added value services that are in green, to introduce a set of capabilities for automation, self-healing, self-optimization, also optimal resource allocation and placement of network functions and applications for verticals, as well as ML-based solution for predictions, and also try to indeed optimize different mechanisms for the different management services. We have identified 3 main blocks inside these pervasive functionalities, which is for closed loop, for automation, for network digital twins to assist the validation of the automation concept, and AML as a service for trying to improve how the AI is deployed in terms of functions, models, and also services for training, validation, and monitoring of AI functions into the network. Then there are also services, more supporting services to enable the different management services to exchange information each other, so exposing their APIs, registering, and also exchange data. And finally, the final exposure towards external domains. These facilitate operator-to-operator communications, but also operator-to-vertical communication and interactions, trying to align also with the GSMA operator platform approach on the one hand, and for the interaction with verticals and applications with the GSMA and Camara approach. Design principles, there are mainly 2 that we are following at the moment. One is the SBMA, so the service-based management architecture that I was already anticipating. So basically allow to define an architecture composed by cooperating management services. So there are producers and consumers. All of the management functions that we have seen in the figure are either consumers or producers. And there is this concept of discovery. So there are not rigid interactions and rigid workflows as in old type of architectures. But the concept is more based on discovering the specific capabilities and also the possibility to have exposure of a specific management service according to specific rules. For example, per tenant or per specific technology or per specific vendor, to allow also different implementations of the same service. The other principle is the intent-based approach that goes beyond, as I said before, the regular approach of having interface where you, for requesting a service or a network service, you have to populate a huge amount of information that is very complex, even to automate. So the intent-based approach allows to request for expectation. So sometimes also in natural language, and this shall be interpreted and let's say translated into something actuable into the network. This brings to one of the first key technological enablers of the proposed architecture, which is indeed the intent management, which means that following what 3GPP says, intents shall be understandable by humans and machines. By humans because the human is the first requester of the intent, and the machines because they should be interpretable and focus more on what is needed rather than how. And so no more details on, let's say, very complex, let's say, JSONs or requests, and should be agnostic of the underlying system. So the interface is agnostic and simple to use. In 3GPP, for example, there are several use cases defined, more network-oriented. Some of them are already approached in some of the projects involved in the Grand Challenge. And they're mostly focused on radio network performance, deployment service at the edge, end-to-end performance optimization, and run energy saving. An aspect important for the Grand Challenge is that the adoption of intent-based interfaces is possible at all the layers and for all the boxes that you have seen in the previous figure. That is aligned also with the 3GPP approach. And intents can be also used to simplify closed-loop automation. So to use intents to express the goal of a closed loop that require then specialized translation mechanism to then translate this intent into something specific that can be monitored, analyzed, and executed. Moving to the next is just an example of implementation of this intent management approach into the super project, where basically there is an implementation ongoing for an ORAN compliant intent-driven management that allows basically to cover 2 of the use cases defined by the GPP. One is for delivering radio service, the other one is for the run energy saving, and is based on an ORAN compliant implementation of the service management orchestrator that expose these intent APIs for, let's say, allowing to request radio services for the run energy saving that are basically invoked on the consumer side by specific run network slice management functions that comply also with the initial architecture that I was showing with these end-to-end network slice management functions. Next enabler that is very much important, I already say a few words about it, is network automation. The complexity of the infrastructure and the softwareization brings complexity in managing end-to-end infrastructures with different domains, different technologies, integration of satellite communications, private networks. So network automation allows to reduce the OpEx, at least in principle, but there are studies that validates this. There are different standard and industry organization that already goes in the direction of, let's say, defining architectures for network automation. TM Forum, more at the service level, defines some reference architectures for intent-driven APIs, closed loops, and autonomous networks, but also integration of AI capabilities into the network. And also ZSM defines a specific closed-loop framework for end-to-end automation. And these are principles that and enablers that are adopted into the architecture and into the projects that contributes to the Grand Challenge. So there are different, of course, implementations in restart of these principles that with the Grand Challenge we are trying to harmonize. An example of an implementation of the network automation principle aligned with ZSM is from Super, where we are implementing a closed loop framework. I don't go into details because the figure is very complex, but we are trying to align with the ZSM approach with a closed loop framework that allows to deploy closed loops on demand for specific tailored automation goals that are can be at different levels, at the resource level, at the network, at the slice, and even vertical application service. Then the last enabler is related to what is called AI as a service. As I said before, this is pretty much aligned with the view of 6G having being an AI native network architecture, so both supporting the view of AI for network and network for AI. There are studies in TGPP, specifically in SA5, on managing IML services, considering different stages and different services for training, deployment, inference, testing of machine learning models, validation, and also retraining in a kind of closed loop way, following the MLOps approach. And also, for example, in European projects, the flagship XX2 project for the 6G network definition are also defining this. And with the Grand Challenge, we are trying to go a step beyond, trying to define this AI as a service concept as a kind of one-shop-stop solution for the deployment and operation of AML services. That means trying to expose and allow consumers to deploy services, AML services and functions into the network, exploring the full cloud continuum. So having a native integration with the cloud continuum, allowing to deploy AI functions for training, even for inference, validation, and monitoring of AI functions into different positions and locations of the infrastructure according to the requirements, for example, of the model that needs to run, for example, close to the data because of privacy, let's say, constraints, rather than for performance because the inference has to be with very low latency. And the idea is also in this case to foster the adoption of open APIs for the management and consumption of these services that allow, on the one hand, to introduce AI into the management of the network to improve automation, and on the other, to deploy AI in the network to assist the operations at the infrastructure level. That is my last slide, which is basically what is going on and what is the next step and goal of the Grand Challenge, which is to prepare and deliver a white paper that is already ongoing. There is an initial draft on its way with some contributions already incorporated. Several projects expressed their interest in the few calls that were run for the Grand Challenge. You see the projects listed there. Of course, as the other Grand Challenges, this is open, so it doesn't mean that others couldn't join. What we are doing now is basically working at two levels. So trying to understand if the figure is complete and also align it with standards, and if there is the possibility through the adoption and alignment with standards to contribute as well to the standards, identifying some gaps on the one hand, and on the other trying to map the different implementations and solutions of the different projects at least participated in now into the architecture as a kind of examples of implementation, or at least of part of the proposed architecture. And so that's it from my side.
One quick question for you. I mean, of course, this is, again, as I said before, an important challenge because, of course, it's covering different aspects and different innovations coming from the different projects that you mentioned. One of the trends that we are trying to analyze, considering the future evolution of the ecosystem, is that of having multiple operators sharing the same infrastructure. Somehow these platforms can be fundamental then for enabling this sharing in a way where you can still differentiate the service offered and also somehow managing the resources available, also somehow differentiating the access to resources depending on who is bringing what.
Yeah.
How do you think this can have an impact on the development of these models, and how the standardization is considering this?
Yeah, the standardization or more industry forums are already going in this direction. I was mentioning in the figure of the architecture this top capability exposure, let's say, function or service that goes indeed in the direction of aligning with what GSMA, which is the industry forum for operators, is defining for this operator platform, where they have options for federating, for federations across operators to exchange resources, but services as well, and also enable also verticals to be in the loop. Because I think one thing that was not pretty much achieved in the 5G roadmap was the integration of verticals as well, because it's one of the key topics also here. So trying to then offer advanced and additional added value services to verticals. Of course, to do this, collaborations among operators are an added value, and standards and industry forums are going in this direction, and also in the architecture that we propose. This exposure capability is also a very trendy topic now with all of this operator platform plus Camara and Open Gateway. So exposure is one of the key topics also for the research for 6G. So what we are doing here is also aligned with this need and also trend for the coming future.
Thanks, Giacomo. So the next speaker is Piero Castoldi, Scuola Superiore Sant'Anna. And again, we change topic in the optic domain. Optical highways. Piero, yeah. The floor is yours.
Thanks, Antonio. More optical hardware, but also optical algorithms. So I will try to summarize the progress so far on this grand challenge that is quite large and includes several contributions from several projects. Optics is mainly confined in Spoke 1, where there is the structural project Rigoletto that ranges from materials up to control planes. So there is a lot of potential impact on the market, on applications, and on manufacturing industries. EPIC is focus projects and has contributed with questionnaires and also disseminating capabilities of foundries in Italy. Graphics is a focus project on a specific device, an active splitter for passive optical networks. LN is also focused on a specific implementation of a null optical wavelength converter. So these are the level of material and devices. At the transmission level, so point-to-point link, we have contribution from regulator, from SensingNet, and we are going to distinguish them with respect to also digital twin grand challenges, and at the control planes level, at the same way, is contributing both to this grand challenge and the orchestration grand challenge. So this slide is quite dense, but summarizing the impact, where the grand challenge is going to highlight the benefits of the output of the projects involved. So in terms of power consumption, let me remind you that within Restart we have a 25% component on green and a 25% component on circular economy. So we must not forget that this is part of the objective, and there are 50% of other, that includes the rest of contribution. So you see here highlighted in color what are the keywords, or for programmable photonic integrated circuits, focus on devices which are programmable, so not only hardware, but also exposing control interface. For transmission, we highlight the way we can exploit optical fibers in terms of expanding the available bandwidth, so from the multiband to the space division multiplexing, and also hollow core fibers that were not included in the original proposal, but now has become very important. Optical wireless, so the future of Wi-Fi towards Li-Fi, and security. Also, the variability of the optical data plane requires monitoring and telemetry platform. And finally, this variability is controlled by zero-touch architectures that reduces the human intervention. I want also to recall that there is also a project that is covering the non-terrestrial networks that has a portion of optical technology for the ground to space and satellite to satellite communication, and also this can be a result that could be included in this grand challenge. So also summarizing again, so for graphics, objective is to re-implement a fiber-powered active splitter, so definitely a green device. For ELAN is the lithium niobate over insulator technology for implementing an optical conversion. In EPIC, target is about photonic hardware accelerators, and for SensingNet, the value here is the reuse of existing optical infrastructure for telecommunication, reusing it for sensing purposes. We also have included some requirements that has driven technology development. So what technology is improving what KPI in network, both for the data plane and the control plane. And the cross you see in this picture is going to tell you what is the KPI that can be improved by a given technology for the data plane or for the control plane. For example, at the data plane, mainly we rely on improving capacity or energy consumption or security with hardware security. The control plane is more flexible and then can improve more control plane with more KPI with dedicated algorithms for implementing it. Now I have structured the grand challenge by taking areas of impact that comes from the European technology platform Photonics 21 and identifying a few ideas on where we could have an impact with the results of the optics project. So let me first focus on faster computation. One notable example is do I have a pointer? If not, so on the left side, the idea of having photonic processors is the ultimate way of implementing processors. So processors that can do linear operation directly in the optical domain bring basically zero latency processing apart from just the propagation of the signal. And this is very interesting because with some recirculation, you can implement certain linear operation among inputs and return them to the output after some circulation and do this processing just at flight time. On the other side, Elen is showing something that again occurs entirely in the optical domain, an all-optical wavelength converter where you inject a signal at given frequency, so a carrier given frequency, and it is returned by all optically processing at the same domain in a range of frequencies that is tunable. Other remaining in the, let's say, computational area, hybrid circuits are of interest where you combine electronic and photonic device, or you combine bulk and integrated device on the same surface through the so-called flip chip technology. Another interesting results coming from EPIC, and this pertains to the coupling of multi-core fiber or free space communication, is the availability of lenses which can have a flat structure, like on the right side of the slide. So basically a surface which is interposed between the source and the cross-section of the fiber for properly injecting a signal in a multi-core fiber, or a micro lens, a small lens for confining optics in free space. Sorry, too far. Other, again, remaining in the hardware for photonic process, this is the final output that will come from graphics, so an active optical switch that is directly light powered, so there is no need to have locally power supply in the cabinets. Another interesting structure is a polymer waveguide that emits on the upper surface by transmitting horizontally, and this can be useful for different applications, like for example doing Li-Fi or emission that needs to change the direction of light emission, confining the pump signal horizontally. And another structure is a null-optical structure for radio over fiber in serving base stations at millimeter wave signal directly in the optical domain, reusing passive optical network infrastructure. For the transmission side, here the focus is on the perspective of increasing capacity, so transmission speed, reducing latency and reducing attenuation. So reusing existing optical fibers, you can explore outside the windows in unexplored so-called bands. Of course, you might encounter higher attenuation and difficulties in amplification. You need different types of amplifier, but still you can increase the available frequency band in order to increase the transmission speed. This is the approach of multi-band transmission. It is short-term, reusing the existing infrastructure. For future applications, multi-core fibers are fibers which have several cores, and each core has the dedicated transmission capability. Gonna have a testbed on this, and perspectively, the hollow core fibers, those which have a hollow core, so air in the core, can increase by 1/3 transmission speed, and that is, sorry, the transmission, the delay, the propagation delay, that because you travel at speed of light instead of 2/3 of speed of light, but also reduce the latency because you don't have any interposition of material, you just have propagation in air. Another notable outcome will be about the disaggregated optical networks, where you see here on the left of the figure different devices from different vendors and also quite heterogeneous can be made interoperable, provided that you have a proper representation at the monitoring level and the control plane level of what is happening, and you can dimension these links in a proper and way, such that no silent faults or no margins are available in order to keep alive the signals and the links. For security, we are working on coexistence of the QKD distribution on the same physical fiber, like a dedicated channel, instead of have a separate fiber. And this is going to help and simplify the QKD distribution. A notable example of using hollow core fiber is for data center consolidation. So here the idea behind is that if you have lower propagation delay, since in data center propagation delay is significant, basically you can have a consolidation of a data center in a single site, because there is no necessity anymore to have them so close to the final user, because the propagation delay is reduced by 1/3. Sorry, there is an overlap of titles here. The true title is validation testbed. So the testbed in L'Aquila we plan to implement after the cascade call has been included is for the test of QKD secured space division multiplexing transmission. So application of QKD into a real testbed based on space division multiplexer fiber provided by Sumitomo Electric. There are also other fibers being deployed, hopefully before the end of the project, to make the testbed larger than the red portion that is already available. Of course, then there will be the transponder and the dashboard to evaluate the performance. Another validation testbed is for Li-Fi. So this testbed is showing practically how you can implement bidirectional optical communication for consumer electronics. So in principle, a laptop that can be fed by data, for example, relying on LED on the ceiling of a room, and a surface collecting this signal, for example, in the empty surface of the laptop, where you in between the keyboard and the keypad, for example. So optically downlink and infrared uplink so far. Let me also remind the testbed of the project SensingNet. I'm close to the end, where the simultaneous use of already deployed fiber will be demonstrated for sensing purposes and for communication purposes. Last slide is this innovation-driven ideas and perspective that's led by Open Fiber on handling both the green part and the circular economy part of our future network, in which power supply when needed will be 100% on renewable sources. There will be introduction of active devices which are powered by light, so directly powered by the signal, and the reuse of existing infrastructures for example, sensing and other purposes. So without, but it was almost the last slide. Yeah, okay, I don't know why it's more. And this is the last one. So this is our way forward. Exactly this Monday, we're gonna have a meeting, an online meeting, and these are our expectations for what will summarize the work of this grand challenge, a fact sheet and a white paper that is in preparation with this timeline. And thank you for the attention.
Piero, thank you. Quick question for you. I mean, there is a lot of expectations for innovations like the hollow core fibers and this kind of stuff. Do you think this is probably the best, the next big thing in optic, or there are other things that are less visible that can make a breakthrough in the technology?
But for transmission, hollow core will be, I think, it will be quite interesting. I was just discussing with a colleague in the break that Microsoft planned to install a significant amount of hollow core fiber for their own infrastructure. So I hope this will not be only for the big players, right? But yes, also for the normal users. So, but this market has, I mean, Microsoft have seen that this is a very promising technique. And so
they're investing a lot.
Yeah, they're investing a lot. So I hope that it will come also for the general public and not only for the over the top.
Thank you. Thank you again. Great. The next speaker is Enrico Magli. I don't know if Enrico is arrived already. Yes, yes. Great. Again, another big change of topic. Now we move to media. Thank you, Enrico.
Thanks. So, well, this is what I have. Maybe someone uploaded the wrong slide set. It's going to take a while, yeah. Or I can use my laptop if needed.
Using the laptop is a problem. So maybe, what if we make a quick switch, Giacomo? You can have the talk and then you fix the presentation. Okay?
Sure.
Okay, so we switch. We have Giacomo Verticale first, and then Enrico.
Yeah, but
okay?
for the record, I did send the slides.
Of course, it's not your fault. Okay. So Giacomo Verticale, this is the last grand challenge that we added on the cooperation for open source projects within Università and also open data. So in a moment, we hope we will have the slides on. Yes, great.
Thank you. Okay, so the goal of the challenge. Yeah, sorry. The goal of the challenge is to do that 10% that Professor Blefary mentioned at the very beginning, which is the additional work that maybe you didn't think about doing, but it would make a great contribution and it will help pushing Restart products to the general public, to other researchers, to companies, even more. 10%.
10.
So our goal as a grand challenge is to support the reuse of Restart output. In the proposal, we committed to publishing our outputs as open source software and as open data. And this challenge will help advertising the availability of these products and help make these products more reusable. So far, we have an inventory that contains 19 open source products and 6 open data sets. I think as a beginning is a good result, but I hope that in the last year of the project, many more open source products and data sets will be published. So please work on preparing your data, and if you need any support, reach me and let's talk. So where is the inventory? You can go to Fondazione Restart webpage, mission 7. There is a table that contains all the published papers, all the open source contributions, all the open data contributions, and you can also add your contribution, where you can add that in our private area. There is a password. I think many of you already know the password, and if you don't know it, ask to your PI. No, because it goes on the website, and so we have trolls using password. So far we have substantial contributions for structural projects. They have produced the bulk of the open source and open data. In particular, we have Rigoletto, 36% of the open source software, thank you, and then FunMedia, Netwin, and so on. I think that focused project can push more products to our inventory. When it comes to the data sets, we have 3 contributing projects, IN, Super, and FunMedia. In terms of partners, there's a significant group of partners that have contributed, Politecnico Milano, Padova, and CNR, and for the data sets, Sapienza and Bari. So what are the actions that we are doing as a grand challenge? First, Improve reusability. So we have produced a number of guidelines to improve the quality of open source submissions. The main problem that we have with open source is that in many cases the published software is the product of a student doing work for a thesis, and so it's not very reusable. So we give a number of guidelines to improve the usability with as little as effort as possible. And then we are setting up a reviewer panel, so a committee, that will look at the actual submissions and provide feedback to improve its quality. And the second action is the dissemination of the content of the inventory by means of a newsletter that I will call the treasure chest. So it's a chest full of very useful products, and you just need to open it and go through it. And we will publish through the dissemination channels, and we are doing some liaison with other activities. So we have a number of guidelines. In particular, for open source software, we have a document. It's a short document, so not much effort to read it. The document was sent on the Ricercatori mailing list. I will send it again, and I think we can also find a location to put it on the Fondazione website. The reason why we have those guidelines is that open source is not just the code, but is adhering to a set of best practices to ensure that whoever picks up the code has a usable license, has an ecosystem, and finds something which is up to standards. A brief review of the guidelines. Of course, you are invited to go through the guidelines yourself. We ask you to put the code on a public repository, so not behind a paywall, and that's it. We recommend GitHub. We ask you to have an explicit choice of license, so to clarify what are the rights of whoever picks up the code. We recommend MIT license. In particular, we have found that many researchers use licenses that do not allow commercial use. So please, if you are considering licensing your code, please allow commercial use, because that would greatly improve reusability. Then we ask to provide a contact point for bug reporting and a minimal commitment to fix bugs in the first months after the release of the code. And finally, we ask you to provide installation, usage instructions, and a minimal set of examples to help potential adopters to verify that the code fits their needs. Then, with the help of a committee, we will go through the submissions and will provide badges. Badges that give information. So we give validated information to potential adopters about the maturity level of the code. So we have a first badge, which is the code is available, which means that it's publicly available and it's structured according to the guidelines, so there is a license, there are instructions, and so on. The second kind of badge is reproducible. In the case of reproducible, it means that the reviewer actually managed to install the code and run the examples. So we provide information about to potential adopters that someone actually managed to use the code. And finally, the best rate that we can give is reusable, and we give that badge if the software structure is documented and the reviewer can actually run the software with own provided data, so more than the examples. And of course, we need volunteers for this job, so please volunteer for doing this service, which in its simplest form is download the code, run the code, and provide feedback to the authors. I managed to run it, I had an error, and please fix the error in order to have a running code. Yes, please? Please go ahead.
I'm coming. Quick question.
Posso farlo in italiano, no? Vai nella slide, ok, meet recommended. Cosa succede se io nello scrivere il software ho usato una licenza che non è MIT?
Questa è una raccomandazione, okay? So we recommend MIT license because the MIT license allows commercial use, which means that there is a wider public that can use the code, and there are fewer restrictions about libraries and other stuff that you can do. Of course, you maybe are bound to use licenses because you are contributing to some other project that has already a license, of course. So whatever the license, as long as it's an open source license, is fine. If you have to pick a license among all the licenses that exist, we recommend using MIT, and that's it. It's just a recommendation. We also looked at the issue of open data, and we chose to not provide guidelines. The environment is too heterogeneous, too many different needs, and so on. So we do not provide guidelines. We just invite authors to follow the best practices relevant for their ecosystem. If you need help, we can provide you some guideline documents, best practice, but it's really field specific. So I expect you to do a minimum amount of research to choose what to adhere to. Regarding the publication, we suggest using Zenodo, which makes sense if your data is a set of files, not too large, so in the order of the gigabytes, and can be published as CSV, Excel, whatever. Zenodo, go for it. If you have different needs, we have been in talk for other platforms, but we decided they were not general enough for our needs. But if you have some needs, let's talk about that. It's not in the slide, but I will periodically ask you to provide some download metrics of your contribution, because we have a commitment to measure the download metrics. So please structure your contribution in a way that you can provide the download metrics. As I mentioned, we are going to write a treasure chest newsletter in which we will provide an annotated list of our contributions, and we will send it to internal researchers and to external researchers. So I will ask you some help to describe your products. We will first send it to internal researcher because we hope that in the last year of the project, some of you, by going through the list of the projects, will come out and say, I'm very happy that I found that another project provided data, provided a piece of software that I could use in my own research. So that would be a great result if many of you next time tell me, I found something useful in other work. So, call to action. First of all, upload your products to the inventory according to the guidelines. There's a minimal effort, so the guidelines are structured in a way not to scare you. So you are invited to upload your product. Use restart products in your research. That would be a great result. And please volunteer for the committee that will review the submissions and assign the badges. I will provide the pointers to volunteer for the committee, and I will send again the guidelines. So, thank you.
Thank you, Giacomo. Thank you. We move to the next presentation because we are a little bit late. So thank you. Maybe the question for you can be answered offline, like how to make a successful open source project that with millions of downloads. But this is another story, right? So let's continue with Enrico. So hopefully the problem with the presentation has been fixed. Great.
Okay,
Great.
now that is it. So this is about Grand Challenge number 9, integrate media and networks. So actually I'm leading 2 Grand Challenges. They're both mostly contributed from the project Fund Media. One is integrating media and networks, and the other one is about detecting deepfakes. We're essentially considering them as 2 aspects of the same coin. Immersive true media and immersive fake media. So we will be handling them together. And if any of you is interested in any of these, please send me an email and we can integrate you into the activities. The project is actually also contributing to the Grand Challenge number 12 about AI, which has been presented by Sergio earlier. So I will talk about 3 topics, essentially. The first is immersive audio. Networked music performances are one of the most interesting types of immersive media because it does take into account both the media and the network because of latency and bandwidth reasons. So I will present work that has been done by Polytechnic of Milan and then CNIT and other entities as well. First activity is spatial audio for immersive media. Here, the scenario is that we have a person that wants to remotely attend an event, and the person can navigate through the event and hear the audio exactly as if he or she were in the room. So this requires, this is a problem of sound field reconstruction. Essentially, it requires having multiple microphones scattered around the environment that the music or performance is played. And there's a lot of signal processing involved in reconstructing the sound field. So the setup for this is we have several microphones, as I mentioned. Every microphone takes a measurement of the sound pressure distribution, and then the overall sound field is estimated. And in the past, this has been done a lot using model-based techniques, where obviously the way that the sound pressure, let's say, is distributed over an environment can be modeled rather easily. So compressive sensing has been used as a sparsity prior for this reconstruction problem, but model-based techniques are somewhat limited by the handcrafted formulas that the engineer, that the researcher can write. Lately, you have a new generation of deep learning techniques, which on the other hand do not require any assumption on the model. They just learn the parameters of the model. They're very powerful, but their performance depends on the data and they're hard to interpret, and therefore the activity that is going on is to put these 2 things together to have to use what we call physics-informed neural networks. This is a specific type of neural network different from others. So usually neural network, you expect to get some data in and to get an answer out. This is different. The input to these implicit neural networks are spatial coordinates of the point for which we would like to know the sound pressure. and the network parameters encode the sound pressure distribution. So you can just query this, and you can query with continuous coordinates, not discrete coordinates. So you get a continuous representation of the sound pressure distribution, and this can be trained using a loss function that involves a fidelity term, so that you want the sound pressure distribution to be, let's say, as accurate as possible to the measurement, but also some physics-based term that makes sure that the statistics of what you get are, let's say, are well represented by the models that we know work well for this problem. And there's a bunch of applications for this in terms of reconstructing a room impulse response, upsampling microphone arrays, and so on. So more work, very much in touch with the network, is aimed at exploiting as much as possible the features provided by 5G networks and beyond for low latency, efficient music performances. Here, the idea is that if possible, we would like to use multi-access edge computing in order to limit the latency, possibly making sure that the information that has to be exchanged between a sender and a receiver doesn't go all the way up to the core network and then back, because there might be bottlenecks in the core network which might increase the latency and make the experience less immersive. So, especially if people playing together in a network music performance are not too far from each other geographically, then we can avoid this by properly managing at the network level. So not involving all the layers in the protocol stack. And another one is related to an interesting business case of producing music where you have an engineer in a control room, you have musicians in a production room, and you have an audience in an event room. All of them use spatialized audio, which can be controlled remotely, so that the engineer, the audio engineer, can provide the musicians with what they want and can provide the audience with what they want, all of these being done remotely. So for this, there's a demo that is available, that has been run at a conference, Internet of Sound, using the public internet network with some specialized audio over IP devices in order to limit the latency of the communication. So the project is not, the challenge is not just about network music, there's more. One interesting thing where we have quite a lot of effort going on is biometrics. So biometrics can be used both to increase the engagement of the user for the immersivity and also to protect their privacy during the immersive media session. So we have two cascade projects in Fun Media which deal with this, covering these different aspects of biometrics in immersive communications, from user recognition to compression of the biometric signals, and also data formats that can be used to gather different biometric traits into the same file. For biometric recognition, things that we're doing is to use biometric trace to allow continuous passive authentication of the user. So anytime you access a service, you need to authenticate, but in continuous authentication, this is done over and over to make sure that the person that is using the service is always the authorized person. As I mentioned, new compression methods, also using wearable devices to acquire biometric traits, because they are very convenient. The biometries can be acquired anywhere, at any time. And also, some of the biometries help us understand if the user is really engaged. I mean, if they're sleeping in front of their monitor, or if they're very actively involved in a media session. And also protecting these biometries from violations and attacks in order to prevent any possible malicious attacks on the media sessions. And also in terms of immersivity, we're studying quality of experience, which can be used also in many ways. The first is just to adapt the content to the user based on their preferences, their needs, and so on. And the other one is also to measure the amount of engagement that the user has, and to understand if the data that we are sending are really the right data for the user. So on this, we're also preparing some demos that hopefully will be showed at the end of the project. And last but not least, the Grand Challenge 17, which is about the fake media. So this is a problem that we are reading about every day these days in the news. everyone is now able to generate images and videos. So images, everybody knows how to do this. There's a lot of free tools. And now this is being extended to video. This is one of the most active areas in computer vision. So we distinguish between two different types of, let's say, media generation. One is deep fakes. That is when someone is trying to pretend that something is something else, and the other one, or someone is someone else, and the other one is synthetic media, which are not necessarily fake, are simply computer generated by artificial intelligence, not necessarily in order to manipulate the information, but maybe to improve the information. So the ability to create, let's say, synthetic media so easily is problematic because this can create a host of problems in terms of generating fake information, people pretending to be someone else from who they actually are. And this is also problematic in media communications because it's not difficult to pretend to be someone else by showing a video with a different face. So there's a lot of work going on in the project on this. We are considering essentially 3 types of media: speech, image, and video. Each of those has their own specific aspects and their own models for fake detection. So the objective is quite simply to be able to say if any of the pieces of media are real or fake. So essentially this is a classification problem, and we mostly use neural networks to do this. The one interesting thing that we're doing is to focus on multimodality. So it is possible to determine whether a given piece of media is true or fake, but it's even more interesting if we can combine the media and perform joint deepfake detection on audio and video. So this essentially amounts to extracting features from each of the media streams, image or video and audio, and cross-correlate them in such a way that we can make a joint decision where the audio-visual piece of information is real or fake. And an important thing when we perform deepfake detection is to provide some intuition about the meaning of the results that we get, not just true or fake. In audio, for example, this means that the deepfake detector could not just provide a binary answer, but also provide information as to which frequencies in the audio signal have been deemed to be, let's say, a feature that is fake, something that has been tampered with by the media generator. And for video, for example, in addition to doing this, it is very interesting to have, because video is a more complex signal, to have a heat map which describes which parts of the video have been tampered with. With audio, it is typically the whole audio or the most part. With an image or video, it might be a small part. So we might have images on which only a very small part, like the face of the person, is being tampered with. And that is all I have. So if anybody is, sorry for, making, being between yourselves and lunch. And if anybody is interested in contributing to this, we're more than welcome to collaborate with other projects or people.
Thank you. Very quick question, and then we conclude the session. You mentioned immersivity at the beginning as the key characteristic of the work that you are doing. For some media, like video, for example, augmented reality, this really depends on the device that you use, and apparently all manufacturers are trying to find the ideal solution to the device. How can this evolution on the device side can influence the research on the media itself and the processing?
Well, quite a lot, I would say, but it's hard to describe how. Meaning, for a long time, we had, let's say, 3D television with depth, and it didn't work, and it didn't work mostly because of the devices were not up to par. So that's the reason why every company is now developing their own standards and so on. So I would say because this project is not about generating new devices, we're essentially looking at what's happening, and we're using what is available, and we're providing functionalities that are as much as possible device independent. For example, the biometries are something that can be added to any device. The quality of experience can be tested on multiple devices. So we're trying to do work that is not device specific because there is no standard at this stage on this topic. But that's a very good point. So most of the limit of immersivity these days is about the devices not still being so usable. For various reasons, really, whether the experience is not really immersive or they require batteries that are too big, and therefore you can use the device, but just for a few minutes, and so on. So yeah.
Thanks, Enrico. Thanks again. Great. So now we have the lunch break, and considering how the coffee break was, we have big expectations, Ilenia. There will be 1 hour, so we will have the next session, which will be the industry panel number 1 at 2 p.m. sharp. So be sure to be here. Don't forget that we have the posters and demo, and don't forget to support your preferred posters and demos. Enjoy the lunch.